At 0314 local time on November 12, 2025, a Russian night shift supervisor at the Ryazan oil refining complex was busy pouring his third cup of coffee, completely unaware that a Ukrainian long-range strike drone had been circling his facility for the last 11 minutes. In exactly 88 seconds, the distillation column he was monitoring, a critical piece of infrastructure responsible for processing 22% of the aviation fuel for the Western Military District, would cease to exist as a functional industrial asset. The supervisor checked his monitors, which showed standard pressure readings and nominal flow rates, oblivious to the fact that his quiet Tuesday morning was about to become a defining case study in modern asymmetric warfare. Above him at 4,000 feet, the Ukrainian-made Lyuty drone was fighting a 30-knot crosswind, its Rotax engine humming at a frequency specifically tuned to blend in with the background noise of the heavy industrial machinery below. This was not a random act of harassment. It was the opening move of a synchronized offensive that would target over 50 strategic sites deep within the Russian Federation. The drone lurking in the darkness above Ryazan was a marvel of pragmatic engineering, representing a masterclass in cost-effective lethality. While Russian defense contractors were busy billing the state millions for hypersonic missiles that may or may not work, Ukrainian engineers had taken a different approach. They built a slow, deliberate, and terrifyingly accurate flying bomb using commercial-grade components that you could technically buy online if you knew where to look. The airframe was constructed from fiberglass and epoxy composites, materials that reflect radar waves about as well as a wet cardboard box, giving it a radar cross-section similar to a large seagull. Its guidance system did not rely solely on satellite navigation, which the Russians had been jamming with increasing desperation across the entire European theater. Instead, this particular variant was equipped with a terrain reference navigation system, essentially a digital map stored on an onboard hard drive that allowed the drone to see the ground using a radar altimeter, matching the terrain contours against its internal database. It was flying blind to GPS, but perfectly aware of its location relative to the ground, immune to the electronic noise being pumped out by the Krasuka 4 electronic warfare systems stationed 10 miles to the south. The path to this target had been plotted with the kind of meticulous detail usually reserved for a moon landing. The operators back in Ukraine had routed the drone through a complex web of radar shadows, utilizing the curvature of the Earth and the natural valleys of the Russian landscape to hide its approach. For 6 hours, the drone had traveled at a leisurely 90 miles per hour, crossing 500 miles of hostile airspace without triggering a single alert. It had skirted the engagement envelopes of 3 separate S-400 batteries, exploiting the known downtime schedules of Russian radar crews. Information likely provided by a network of partisans or purchased from corrupt officials who valued hard currency over operational security. The math was brutal for the defenders. They had to be lucky every single second of every single day to stop these attacks, while the Ukrainian drone only had to be lucky once. And tonight, luck was entirely on the side of the attacker. The drone's 75-pound warhead was not massive by military standards, but it did not need to be. When you can place a shaped charge within 2 meters of a pressurized catalytic cracker, physics does the rest of the heavy lifting for you. As the clock ticked down to 0315, the drone's onboard flight computer initiated its terminal dive sequence. The engine throttled back to reduce the acoustic signature, turning the aircraft into a silent glider for the final approach. This was the most dangerous phase of the mission. The drone had to drop from its cruising altitude of 4,000 feet down to just 200 feet, bringing it well within the range of the Panzer S-1 air defense systems protecting the refinery. The Russian radar operators should have seen it. The Panzer's phased array radar is theoretically capable of tracking targets moving at twice the speed of sound, yet it struggled to lock onto a slow-moving composite glider coming in at a steep angle. The operators in the control vehicle were likely fatigued, staring at screens filled with the static clutter of a busy industrial zone. By the time the automated systems finally registered a high-priority threat and slewed the 30mm cannons toward the incoming vector, the geometry of the engagement was already hopeless. The drone was inside the minimum engagement range, moving too low and too fast relative to the ground clutter for the radar to maintain a solid lock. At 0316 and 4 seconds, the Lyuty drone impacted the primary fractionation tower with absolute precision. The explosion was not the Hollywood-style fireball that most people expect. At least not initially. The primary detonation punched a hole through 3 inches of reinforced steel, instantly depressurizing a vessel containing superheated crude oil vapor at 400 degrees Celsius. The sudden drop in pressure caused the liquid inside to flash boil into an explosive vapor cloud that expanded outward at supersonic speeds. Less than a second later, this fuel-air mixture found an ignition source, likely a hot pipe or a spark from the tearing metal, and the real destruction began. A massive secondary explosion ripped through the facility, shattering windows 3 miles away and sending a column of black smoke 2,000 feet into the night air. The shockwave knocked the coffee cup out of the shift supervisor's hand and threw him against the control panel, his screens instantly flashing red with hundreds of catastrophic failure warnings. But this strike was just the beginning. Across the breadth of Western Russia, from the fuel depots of Rostov to the microelectronics factories of Tula, dozens of similar drones were entering their final attack runs. This coordinated strike package was the culmination of months of intelligence gathering and technological refinement. Ukrainian planners had realized by late 2024 that hitting the front lines was not enough. They had to strangle the logistics that kept the Russian war machine fed. They identified over 50 critical nodes, refineries, ammo dumps, and specialized manufacturing plants that represented the bottlenecks of the Russian industrial base. The beauty of this strategy lay in its economic asymmetry. The drone that just vaporized a $50 million distillation tower cost roughly $45,000 to build. That is a return on investment of over 10,000%. Even if the Russians managed to shoot down 80% of the incoming wave, the cost of the interceptor missiles alone would exceed the cost of the entire drone fleet. And the remaining 20% of drones that got through would cause billions of dollars in damage and months of downtime. It was a strategy of attrition where the attacker held all the financial cards. The Russians were being forced to use million-dollar missiles to shoot down flying lawnmowers, a sustainable exchange rate only for the side building the lawnmowers. The scale of this offensive became apparent as dawn broke over the region. Social media channels began to flood with videos filmed by terrified locals, showing plumes of smoke rising from multiple strategic locations. In the Voronezh region, a swarm of 5 drones targeted a major ammunition storage facility. Here, the Russians were better prepared. They had deployed electronic warfare jammers that scrambled GPS signals across a 50-mile radius, creating a navigational dead zone that should have blinded any incoming threat. But the Ukrainian engineers had anticipated this. These newer drones were equipped with optical terminal guidance, a system that uses a small camera and an onboard AI processor to visually identify the target in the final moments of flight. As the drones entered the jammed airspace, their satellite link severed. The AI took over. It compared the view from the camera with reference images of the ammo dump stored in its memory. It recognized the specific shape of the storage bunkers, ignoring the camouflage netting and decoy heat sources the Russians had set up. The first drone took a hit from a heavy machine gun and spiraled into the trees, but the remaining 4 adjusted their flight paths autonomously, spacing themselves out to strike different sectors of the depot simultaneously. The impact at Voronezh was seismic. One of the drones managed to penetrate a hardened concrete bunker storing 152mm artillery shells. The shaped charge warhead jetted through the reinforced door like a hot knife through butter, igniting the propellant charges stacked inside. The resulting earth-shattering kaboom registered as a 2.3 magnitude seismic event on sensors hundreds of miles away. It wasn't just an explosion, it was a chain reaction. Cook-offs from the burning munitions sent shrapnel and unexploded ordnance flying into adjacent storage areas, starting fires that would burn for 3 days. The local fire brigades could do nothing but set up a perimeter and watch it burn, as the heat was intense enough to melt the asphalt on the approach roads. This single strike effectively erased the artillery supply for an entire Russian Army Corps for 2 weeks. And while the physical damage was immense, the psychological impact was even greater. The message was clear. There was no safe harbor. No matter how deep inside Russia you were, no matter how many air defense systems you parked outside the gate, you were reachable. Meanwhile, 300 miles to the north, a different kind of drama was unfolding near a specialized microelectronics plant in the Tula region. This target was smaller, but arguably more valuable than the massive fuel tanks or ammo dumps. This facility produced the guidance chips for Russia's precision-guided munitions. Taking it offline would bottleneck missile production for months. The attack here utilized a different vector entirely. Instead of a swarm, a single high-speed, jet-powered drone, a modified Paleonitsia, was streaking toward the target at 400 miles per hour. This was not a slow glider. It was a cruise missile in all but name, and powered by a small turbojet engine that gulped fuel at a ferocious rate, but provided the speed necessary to punch through heavy air defenses. The Russian radar operators tracked it, but the engagement window was razor-thin. At that speed, the drone crossed the entire engagement zone of a Tor M2 system in less than 40 seconds. The air defense crew managed to fire 2 missiles, but the drone performed a high-G barrel roll maneuver programmed specifically to bleed the energy of incoming interceptors. It was a move that stressed the composite airframe to its breaking point, the wings flexing alarmingly under the G-forces. The first Russian interceptor missile exploded 50 meters behind the drone, the shrapnel shredding the drone's rear stabilizer, but failing to hit the engine or the warhead. The drone shuddered violently, its flight computer fighting to maintain stability with damaged control surfaces. It began to roll to the left, losing altitude rapidly. For a moment, it looked like the mission was a failure, a pile of expensive debris about to plow into a potato field. But the guidance software compensated, applying full deflection to the remaining ailerons and throttling the engine to maximum power to power through the instability. It was flying sideways, leaking hydraulic fluid, and screaming like a banshee, but it was still on course. The target building, a sterile clean room facility with a distinct white roof, loomed ahead. The drone didn't have the altitude to dive, so it went for a direct horizontal impact. It slammed into the side of the building at 380 miles per hour. The kinetic energy alone enough to compromise the structure before the 50-pound warhead even detonated. The blast collapsed the roof of the clean room, exposing delicate lithography machines worth tens of millions of dollars to the dust, smoke, and fire of the outside world. But the systematic dismantling of the Russian war machine did not stop with factories and fuel depots. At 0500 hours, just as the fires in Ryazan and Tula were being upgraded to 5-alarm catastrophes, a second wave of Ukrainian drones crossed the border, targeting the electrical backbone of the Russian industrial West. The target was the 500-kilovolt substation at Kaluga, a critical node that steps down high-voltage transmission lines for regional distribution. These transformers are massive, oil-filled beasts weighing over 200 tons, custom-built with lead times of up to 18 months. You cannot just pick one up at the local hardware store. When a drone carrying 50 pounds of high explosive impacts the cooling fins of a transformer, it punctures the oil reservoir and ignites the mineral oil inside, creating a fire that burns at temperatures hot enough to weaken the structural steel of the gantry towers. The initial strike at Kaluga didn't just knock out power to a few neighborhoods, it tripped safety relays across 3 adjacent oblasts, causing a cascading grid failure that plunged nearly 2 million people. And more importantly, 4 major defense contractors into darkness. The backup generators at these plants take time to spin up, and for delicate manufacturing processes involving chemical reactions or precision heating, a sudden power cut ruins entire batches of production. The brilliance of targeting the electrical grid lay not in the immediate blackout, but in the logistical nightmare it created. Russian repair crews were already stretched thin, and replacing a custom-built high-voltage transformer is a monumental engineering task even in peacetime. Under the threat of constant double-tap strikes, where a second drone hits the same target 30 minutes later to kill the repair crews, maintenance becomes a lethal profession. The psychological toll on the utility workers was immense. By attacking the power infrastructure supporting the military-industrial complex, Ukraine forced Russia to divert precious air defense assets away from the front lines in the Donbass to protect substations deep in the rear. Every Pantsir-1 system parked next to a transformer in Kaluga was one less system shooting at Ukrainian jets over the front lines. It was a masterclass in strategic dilemma. Protect the army or protect the economy? The Kremlin tried to do both and ended up doing neither effectively, leaving gaps in their air defense coverage wide enough to drive a truck through, or in this case, a swarm of slow-moving propeller drones. As the sun fully rose, the scale of the operation's success became impossible to hide. Commercial satellite imagery providers began uploading high-resolution photos of the targeted sites, confirming significant damage at over 38 distinct locations. At the Engels 2 airbase, home to the strategic bomber fleet, the imagery revealed the scorched silhouette of a Tu-95 Bear bomber on the tarmac. These aircraft are the dinosaurs of the Cold War, irreplaceable nuclear-capable assets that Russia relies on for missile launches. A drone costing less than a mid-range sedan had managed to penetrate the layered air defense of a strategic nuclear base and damage an asset worth hundreds of millions of dollars. The drone didn't even need to destroy the bomber completely. Shrapnel tearing through the fuselage and avionics bays renders the airframe unflyable for months. In the calculus of attrition, trading a $20,000 drone for the indefinite grounding of a strategic bomber is a trade that would make any military accountant weep with joy. The visible scorch marks on the tarmac were a testament to the fact that Russia's vaunted air defense umbrella was more like a colander, full of holes and leaking everywhere. The economic repercussions of these strikes began to ripple through the Russian economy within days. The hit on the Ryazan refinery, combined with strikes on 2 other fuel depots in the south, effectively took 15% of Russia's refining capacity offline overnight. In a country that runs on oil exports and diesel-hungry tanks, this was a critical blow. Wholesale fuel prices in the Moscow region spiked by 40% within 48 hours. The Russian government was forced to implement emergency export bans to keep domestic prices stable, further cutting into the revenue streams needed to fund the war. It was a death by 1,000 cuts. No single strike won the war, but the cumulative effect of 50 deep strikes created a logistical friction that slowed everything down. Tanks at the front waited longer for fuel. Artillery units rationed shells because the ammo dump in Voronezh was still smoldering. The factories building replacement parts were dark because the substation in Kaluga was a twisted wreck of copper and steel. The friction was palpable, grinding the gears of the Russian military machine to a halt. By the time the smoke cleared in late November 2025, the Deep Strike campaign had rewritten the rules of engagement. It proved that a smaller nation, utilizing asymmetric technology and precise intelligence, could hold a superpower's strategic infrastructure hostage. The 50-plus strikes didn't end the war that winter, but they fundamentally altered the trajectory of the conflict. They forced Russia to internalize the cost of the war, bringing the fire and destruction from the trenches of Ukraine to the doorsteps of the factories in Tula and the refineries in Ryazan. As winter set in, the Russian logistics officers looked at their burning depots and frozen supply lines and realized that the cold was the least of their worries. The real problem was the buzzing sound in the sky, the sound of a cheap plastic drone carrying a shaped charge and a one-way ticket to the nearest fuel tank. And as for the Russian leadership, they were left with a very expensive lesson in modern warfare. Occupying land is easy, but holding on to your own infrastructure when the enemy can reach out and touch it from 500 miles away is a whole different ballgame. At 0214 hours on February 1st, 2026, a Russian commander inside the concealed Rubicon Center of Advanced Unmanned Technologies was likely feeling invincible, completely unaware that a Ukrainian Shark reconnaissance drone had been circling 22,000 feet above his position for the past 43 minutes. In exactly 92 seconds, this elite testing facility located near the Kursk and Donetsk border would transition from a state-of-the-art command hub into a crater of twisted metal and shattered concrete. The Rubicon unit was not your standard conscript outfit. This was the brain trust of Moscow's drone warfare evolution, a specialized group dedicated to testing and deploying fiber-optic-controlled drones that were theoretically immune to electronic warfare. They believed their hardwired connection to their birds made them invisible to the electromagnetic spectrum hunters that usually pinpoint drone operators. But while they were right about the radio silence, they forgot that heat signatures and visual patterns are impossible to mask from high-altitude optical sensors. The Ukrainian operators were not looking for radio waves. They were looking for the subtle rhythm of a logistics trail that led straight to the Rubicon's front door. This facility represented the pinnacle of Russian adaptation in the drone war, specifically designed to counter the intense electronic jamming that had rendered standard radio-controlled quadcopters useless in many sectors. The engineers at Rubicon had bet everything on spools of fiber-optic cable, a technology that physically tethers the drone to the controller with a strand of glass no thicker than a human hair. This innovation meant that no amount of frequency jamming could sever the link, allowing their pilots to fly with perfect video clarity right up until the moment of impact. However, this feeling of technological superiority had bred a fatal complacency among the staff. They assumed that because they were emitting no radio signals, they were ghosts. But ghosts do not need diesel generators to charge battery banks, and ghosts do not have supply trucks making regular deliveries of fresh spools and warheads. At 0230, the thermal sensors on the lurking Ukrainian drone picked up the heat bloom of a heavy generator exhaust venting against the freezing winter air, a beacon of infrared light that screamed high-value target to anyone watching with the right equipment. The intelligence picture had been building for 72 hours, pieced together by a fusion of satellite imagery and partisan reports from the occupied territories. The analysts had noticed a peculiar pattern of vehicle movement that did not match standard troop rotations or supply runs for the infantry trenches. These were specialized electronic warfare vans and covered transport trucks moving with a security detail that suggested something far more valuable than artillery shells was being moved. By cross-referencing the license plates and the unit insignias captured by long-range optics, Ukrainian military intelligence identified the site as the forward operating base for the Rubicon Center. This was the unit responsible for the recent plague of unjammable drone strikes that had been terrorizing Ukrainian logistics columns. The decision to strike was made not just to destroy a building, but to send a message that no technological workaround could buy safety. At 0232, the coordinates were transmitted via encrypted link to a mobile artillery battery hiding in a tree line 42 kilometers away. The weapon of choice for this surgical removal was the high-mobility artillery rocket system, a platform that has become legendary for its ability to delete grid squares with mathematical precision. The crew of the launcher had received the fire mission and was already spinning up the gyroscopes on a pod of M31 guided multiple launch rocket system missiles. Each missile carries a 200-pound unitary warhead packed with high explosives, designed to penetrate reinforced structures before detonating. But for a target like the Rubicon Center, which likely had personnel scattered across a compound and soft-skinned vehicles parked outside, the commanders might have opted for the M30A1 variant. This terrifying alternative replaces the standard explosive filler with 180,000 tungsten fragments, effectively turning the missile into a massive shotgun blast that shreds everything within a massive radius. As the launch codes were verified, the Russian operators inside the Rubicon Center were likely reviewing flight data from their day's tests, oblivious to the fact that their own location data had just been locked into the guidance system of a rocket that travels at Mach 2.5. At 0234, the silence of the Ukrainian tree line was shattered as the rocket motors ignited, sending a salvo of precision munitions arching into the night sky. The flight time for a GMLRS rocket at this range is roughly 2 minutes. A window of time where physics dictates the outcome, and no amount of human intervention can change the trajectory. The missiles climbed to the apex of their ballistic arc, their GPS guidance fins making micro-adjustments to ensure they would land within a meter of the intended aim point. Back at the target site, the routine of the night shift continued. A sentry might have been smoking a cigarette near the entrance, perhaps looking up at the cloudy sky, unaware that death was currently descending at supersonic speeds. The tragedy of modern warfare is this disconnect between the immediate quiet reality of the target and the violent, complex calculus of the weapon rushing to meet it. The Rubicon engineers were masters of remote warfare, killing from a distance with screens and controllers. But tonight, the equation was being balanced, and they were on the receiving end of the same remote violence they had perfected. The arrival of a GMLRS strike is often described not as a whistle, but as a sudden tearing of the air followed instantly by detonation. At 0236, the first missile slammed into the roof of the main command structure. If it was the unitary warhead, it punched through the concrete and steel reinforcement before the fuse triggered the main charge, overpressurizing the interior and collapsing the building on top of the elite specialists and their equipment. If it was the tungsten variant, the airburst detonation would have saturated the entire compound with a hail of hypervelocity metal, turning unarmored vehicles into sieves and shredding the delicate optical equipment and drone frames stored in the open. The sheer kinetic energy of the impact, combined with the explosive force, would have instantly ignited the lithium-ion batteries stored in bulk for the drone fleet, creating a secondary thermal event that no fire extinguisher could hope to suppress. The unjammable nature of their drones meant nothing when the controllers holding the joysticks were vaporized in a millisecond of expanding gas and shrapnel. Simultaneously, a second and third missile impacted the peripheral structures, likely the barracks and the technical workshops where the fiber optic spools were wound and calibrated. This was a coordinated, double-tap strike, designed to ensure that no equipment could be salvaged and no senior commanders could escape the kill zone. The Rubicon Center, which had been the pride of the Russian military-industrial complex just moments ago, was now a burning testament to the effectiveness of integrated reconnaissance and precision fires. The destruction of the specialized winding machines was particularly critical. These are not off-the-shelf components you can buy at a hardware store. They are custom-engineered devices essential for the fiber optic deployment system. By destroying the manufacturing and maintenance capability, Ukraine didn't just kill soldiers. They effectively paused the deployment of this specific weapon system for weeks or even months. It was a strategic checkmate executed with high explosives, proving that while technology evolves, the vulnerability of the human element remains the one constant in war. As the smoke began to rise, obscuring the thermal view of the shark drone still circling above, the secondary explosions began. These were the telltale signs of a successful hit on a munitions depot. The distinct white-hot flashes of cooking-off drone warheads and the fierce, rhythmic popping of small arms ammunition confirmed that the intelligence had been 100% accurate. The Rubicon unit had been stockpiling thermobaric charges for their next offensive, and now those same charges were consuming the very facility meant to deploy them. The irony would have been palpable if there were anyone left to appreciate it. Instead, the Ukrainian operators miles away simply logged the impact, confirmed the destruction of the target, and began the procedure to bring their drone home. They had just wiped out a high-priority target that had been a thorn in the side of their defense for months, and they had done it without risking a single soldier on the ground. The revenge for the terror caused by the fiber-optic drones was not emotional. It was cold, calculated, and delivered with the indifference of a falling rock. The aftermath of the strike revealed the extent of the damage as dawn broke over the smoking ruins hours later. Russian recovery teams, wary of a follow-up strike, would approach the site to find that the Rubicon Center had effectively ceased to exist. The loss of the specialized commanders and technical staff was a blow far greater than the loss of the building itself. You can rebuild a concrete bunker in a few weeks, and you can ship in new drones from a factory in a few days. But you cannot easily replace the years of institutional knowledge and specialized training that vanished in that 2-second window of destruction. These were experts in a very niche field of electronic warfare and aerodynamics, and their removal from the chessboard degraded Russia's ability to adapt to the evolving battlefield. The strike also forced a change in Russian operational behavior. No longer could they assume that staying off the radio meant staying alive. The psychological impact of knowing that even their most secure, silent bases could be located and liquidated would force them to disperse, to move more frequently, and to operate with a paranoia that degrades efficiency. This operation serves as a brutal case study in the cat-and-mouse game of modern technological warfare. The Russians developed a counter to jamming, fiber optics, thinking it was the ultimate shield. Ukraine countered that counter not with a better jammer, but with better eyes and a bigger hammer. It demonstrates that there is no wonder weapon that grants immunity. Every innovation introduces a new vulnerability, or relies on a legacy system, like logistics or heat generation, that can be exploited. The Rubicon unit's reliance on physical cables made them unjammable, but it also likely limited their mobility and required a more static, infrastructure-heavy footprint, which is exactly what the Ukrainian intelligence analysts used to find them. They traded electronic invisibility for physical predictability, and in the ruthlessly efficient calculus of artillery warfare, predictability is a death sentence. The debris field near the Kursk border is now just another scar on the landscape, but for military strategists, it is a clear lesson. If you stay still long enough to feel safe, you are already dead. But to truly understand why the liquidation of the Rubicon Center was such a critical blow, you have to look past the burning concrete and understand the terrifying technology they were perfecting inside. The Prince Vandal drones developed here were not your standard quadcopters that lose signal behind a thick tree line. These were fiber-optic guided munitions, essentially flying missiles tethered to their operators by a spool of glass fiber, often 10 to 20 kilometers long. This physical connection grants them immunity to all known electronic warfare jamming, because there is no radio signal to jam. The operator sees a crystal-clear, uncompressed video feed right up until the millisecond of impact, allowing them to fly into bunkers, chase helicopters, or hit the weak spots on moving tanks with a precision that radio frequency drones can only dream of. The video feed does not break up, it does not get snowy, and it does not lag. It is like playing a video game with zero latency, except the game ends with a real explosion. The Rubicon engineers believed this hardwired approach was the future of warfare, a way to bypass the electromagnetic spectrum entirely. And for a while they were right, but they forgot that while you cannot jam a glass wire, you can absolutely track the logistics required to manufacture, transport, and deploy thousands of kilometers of delicate fiber optic spools. The destruction of the winding machinery inside the facility is perhaps more damaging than the loss of the drones themselves. You can 3D print a drone frame in a few hours, and you can solder a flight controller in 20 minutes. But winding 10 kilometers of hair-thin fiber optic cable onto a spool that can spin freely at 100 kilometers per hour without snapping is an industrial challenge that requires specialized, calibrated equipment. By destroying the workshop where these spools were prepared, the Ukrainian strike did not just destroy the inventory, they destroyed the means of production. It creates a supply chain bottleneck that cannot be solved by simply ordering more parts from a supplier. The Russians now have to source new winding machines, calibrate them, and train new staff to operate them, all while knowing that their secret location is now a crater on a satellite map. This is the difference between a tactical nuisance and a strategic setback. A destroyed truck is a nuisance. A destroyed production capability is a catastrophe that ripples through the entire front line, leaving specialized units waiting for equipment that will simply never arrive. The human cost to the Russian Specialist Corps is equally severe and far harder to quantify on a spreadsheet. The personnel inside the Rubicon Center were not fresh conscripts pulled from a penal colony. They were seasoned engineers, drone pilots with hundreds of flight hours, and technical officers who understood the intricate physics of fiber optic deployment. In the niche world of advanced drone warfare, this level of expertise is a finite resource. You cannot simply draft a replacement and teach them the nuances of signal propagation and terminal guidance in a week. These commanders were the brain trust responsible for refining the tactics that made the Vandal drones so effective. By wiping out the command staff, Ukraine has effectively decapitated the unit's ability to innovate. The survivors, if there are any, will be scattered to other units, their institutional knowledge diluted or lost entirely in the chaos of reorganization. It sends a chilling ripple effect through the entire Russian drone operator community. If the elite Rubicon unit can be touched, then nobody is safe. It forces every other operator to spend more time looking over their shoulder and less time looking for targets, degrading their combat effectiveness through pure psychological pressure. Let us look at the return on investment for this strike, because in modern war, economics is just as lethal as high explosives. The two GMLRS rockets fired by the HIMARS system cost approximately $160,000 each, bringing the total cost of the munition expenditure to roughly $320,000. In exchange, Ukraine destroyed a facility containing millions of dollars in specialized electronic equipment, dozens of completed fiber optic drones, transport vehicles, and the priceless human capital of the Rubicon leadership. But the real value lies in the opportunity cost inflicted on the enemy. If that unit had remained operational, their unjammable drones could have destroyed dozens of Ukrainian tanks, radar systems, and logistics trucks over the coming months, causing tens of millions of dollars in damages. By spending $300,000 now, Ukraine potentially saved $50 million in future losses. That is a return on investment of over 16,000%, a number that would make any Wall Street hedge fund manager weep with envy. It is a brutal, cold calculus, but it is the math that wins wars. The strike also forces Russia into a defensive posture that inherently reduces their offensive capabilities. To avoid another strike like this, the remnants of the fiber optic drone units will have to disperse, moving their workshops into smaller, less efficient locations, or hiding them deeper in the rear, further away from the front lines. This adds travel time for every resupply, increases the wear and tear on their vehicles, and complicates the command and control structure. They can no longer centralize their maintenance and winding operations for efficiency. They must now prioritize survival over output. Every hour they spend packing up equipment to move to a new hiding spot is an hour they are not flying missions. Every measure they take to mask their thermal signature slows down their workflow. Ukraine has effectively forced them to fight with one hand tied behind their back, not by jamming their signals, but by making the logistical footprint of their operation a magnet for high-precision artillery. It is a classic example of using a kinetic solution to solve a technological problem. Ultimately, the destruction of the Rubicon Center on February 2, 2026 serves as a grim reminder that in the age of transparent battlefields, there is no such thing as a sanctuary. You can hide from the radio frequency spectrum with fiber optics, but you cannot hide from the thermal spectrum, the visual spectrum, or the relentless gaze of a reconnaissance drone orbiting at 20,000 feet. The Russian engineers tried to outsmart the laws of electronic warfare, but they ran headfirst into the laws of ballistics and logistics. They built a system that was immune to jamming but vulnerable to being found, and in the end, being found is the only thing that matters. The fiber optic cables that were supposed to be their lifeline became the breadcrumbs that led to their demise. As the fires burn out and the snow begins to cover the wreckage of what was once an elite research hub, the message to every other specialized unit is clear. You are being watched, you are being tracked, and physics does not negotiate with your survival. At 0200 hours on February 2, 2026, a silence hung over the Kursk border region that was more terrifying than the noise of artillery. To the average infantryman, silence usually meant safety. But to the Ukrainian electronic warfare crews monitoring the spectrum, this silence was a screaming alarm. They were hunting ghosts. Specifically, they were hunting the Rubicon Center for Advanced Unmanned Systems, an elite Russian unit that had fundamentally changed the physics of the drone war. For months, Rubicon operators had been deploying a weapon that defied every countermeasure in the NATO handbook: fiber optic drones. Unlike standard quadcopters that scream their location across the radio spectrum, a fiber optic drone unspools a physical thread of glass as it flies, tethered to its operator like a diver to a boat. No radio signals to jam, no GPS to spoof. No electronic footprint for a sensor to lock onto. To the sophisticated listening stations meant to detect radio frequencies, these drones were simply invisible, holes in the data where a killer should be. But while the drones were ghosts, the men flying them were made of flesh and bone. And they had just made a fatal assumption. They believed that because their weapons were invisible, their base was too. Unknown to the Rubicon commanders, celebrating their recent successes in the officers' mess, a different kind of math was being calculated 50 kilometers away. A Ukrainian Shark-class reconnaissance drone had been loitering in the freezing stratosphere, battling crosswinds and icing sensors to maintain a fix on a nondescript industrial complex near the village of Suja. The complex looked like any other logistics hub. Trucks moving in, crates moving out. But the thermal signature told a different story. The heat blooming from the ventilation systems wasn't consistent with a warehouse. It was consistent with a server farm or a command center running high-performance computing clusters 24 hours a day. Intelligence had engaged in a weeks-long game of pattern recognition, tracking the rotation of high-value vehicles that never appeared on logistics manifests. They weren't tracking the drones, they were tracking the ego of the commanders. The Rubicon unit, confident in their technological superiority, had grown comfortable. They parked their specialized command vehicles in the same spots. They ran their generators at the same times. And at 0215 hours, the pattern confirmed what the electronic silence suggested. This wasn't just a supply depot. This was the brain of the beast. The decision to strike wasn't made lightly because the Rubicon Center wasn't just a military target, it was a research facility filled with Russia's most capable drone engineers. Eliminating it wouldn't just stop a few attacks, it would decapitate the development program for the most dangerous tactical weapon on the front. But the window of opportunity was closing fast. The thermal feed from the Shark drone showed a convoy of heavy transport trucks idling in the courtyard, their exhaust plumes glowing white-hot against the frozen ground. The unit was packing up. In less than an hour, the Rubicon specialists and their fiber optic stockpiles would vanish into the vastness of the Russian interior, resetting the hunt and leaving Ukrainian infantry blind against a threat they couldn't jam. The commander of the Ukrainian Rocket Artillery Division looked at the timestamp. The flight time for a GMLRS rocket from a high-mobility artillery rocket system is roughly 2 minutes and 30 seconds at maximum range. The convoy would be moving in 10. The math was unforgiving. If they launched now, the rockets would arrive while the trucks were stationary. If they waited for a second confirmation, the targets would be mobile, turning a precision strike into a guessing game. At 0218 hours, the firing solution was uploaded to a launcher hidden in a tree line 40 kilometers from the border. The computer didn't care about the reputation of the Rubicon unit or the invincible nature of their fiber optic technology. It simply processed coordinates, wind speed, and trajectory. The HIMARS system is often described as a sniper rifle for artillery, but that analogy fails to capture the violence of the arrival. A sniper bullet punches a hole. A GMLRS rocket delivers a warhead filled with 180,000 tungsten fragments moving at supersonic speeds. It transforms a grid square into a blender. When the 3 rockets left the rails, they didn't roar like a barrage. They hissed into the sky, climbing to their apogee in seconds. To the Russian radar operators monitoring the airspace, the launch would have appeared as a momentary flicker, a fast-moving contact that looked nothing like a slow drone or a conventional aircraft. By the time their air defense systems could calculate an intercept vector, the rockets were already beginning their terminal dive. The physics of the engagement were absolute. Rubicon unit had spent years perfecting a drone that couldn't be jammed, but they had forgotten that a command center that can be seen is a command center that can be destroyed. Back at the Rubicon facility, the first sign that the equation had shifted wasn't a siren or a radar warning receiver. It was the sound. A GMLRS rocket arriving at Mach 2.5 moves faster than the sound it generates. The impact happens before the brain can register the noise. At 0221 hours, the first rocket slammed into the roof of the main command building. The fuse was set for delayed detonation, allowing the warhead to punch through the concrete reinforcement before exploding inside the operations room. In a microsecond, the tungsten rain shredded the server racks, the control stations, and the specialized fiber optic spooling equipment that had been terrorizing the front lines. The second rocket impacted the courtyard, turning the idling transport convoy into a chain reaction of exploding fuel and lithium-ion batteries. The third rocket struck the personnel barracks. The invincible engineers who had mocked the concept of electronic warfare were silenced not by a jammer, but by kinetic energy delivered with mathematical precision. The Shark drone circling above recorded the devastation in high-definition thermal video, the heat signature of the base blooming from a dull gray to a blinding white wash that saturated the sensor. The aftermath of the strike revealed the grim reality of the Rubicon unit's hubris. Intelligence assessments later confirmed that the strike had liquidated not just the operational staff, but the senior technical leadership responsible for the fiber optic program. These were not conscripts who could be replaced with a week of training. These were specialists with years of experience in robotics and signal processing. The loss of the Rubicon Center was equivalent to an Air Force losing its top fighter weapons school in a single afternoon. For the Ukrainian commanders, the strike was a validation of a new doctrine. If you cannot jam the weapon, you must kill the archer. The fiber optic drones were immune to electronic warfare, but the logistics required to launch them were heavy, slow, and distinct. The spools of fiber, the heavy control units, the specialized vans needed to transport the delicate glass wire. All of these created a physical footprint that no amount of stealth technology could hide. The Rubicon unit had bet everything on the invisibility of their connection, ignoring the visibility of their existence. However, the destruction of the Rubicon HQ was only the opening move in a wider purge. As the smoke cleared over the Kursk border, Ukrainian intelligence began to exploit the sudden silence in the Russian drone network. When a command node is destroyed, subordinate units often break discipline. They turn on radios to ask for orders, they move vehicles to find better reception, they panic. In the hours following the strike, the electronic spectrum, which had been so terrifyingly quiet, suddenly lit up with the chaotic chatter of confused operators. Every transmission was a breadcrumb. Electronic jamming were now frantically trying to coordinate a retreat over unsecured radio channels, unaware that their panic was providing the targeting data for the next wave of strikes. This shift from a defensive posture to an offensive hunt marked a turning point in the drone war dynamics of early 2026. For months, the narrative had been dominated by the terrifying inevitability of the fiber optic drone. Soldiers spoke of them in hushed tones, describing the hopelessness of watching a drone approach while their electronic warfare jammers sat useless. But the liquidation of the Rubicon unit shattered that aura of invincibility. It proved that every technological advantage comes with a tactical cost. Fiber optic tether that made the drones unjammable also limited their range and tethered the operators to a fixed location. To fire the weapon, the Rubicon crews had to sit static, reeling out their glass line, unable to move or evade until the mission was complete. The Ukrainians had realized that this wasn't a strength, it was a fatal vulnerability. They stopped trying to defeat the drone and started hunting the stationary vans and the hidden antennas. The destruction of the Rubicon Center created a logistical shockwave that traveled faster than any fiber optic signal. Inside the burning wreckage of the command post, something far more valuable than brick and mortar was being consumed by the flames: the proprietary supply chain of the fiber optic war. The specialized spools of glass filament used in these drones are not off-the-shelf components found in a hardware store. They are precision-engineered microfilaments capable of unspooling at speeds of 100 kilometers per hour without snapping. They require climate-controlled storage and delicate handling, or the glass becomes brittle and useless. The GMLRS strike had not just killed the operators, it had detonated the unit's central stockpile of this critical material. As the fires raged through the storage annex, millions of dollars in specialized optical cable melted into a useless slag of silicon and plastic. The Rubicon unit hadn't just lost its brain, it had lost its nervous system. Without these spools, the surviving field teams were effectively disarmed, forced to revert to standard radio-controlled drones that the Ukrainian electronic warfare units were already waiting to jam. The math of logistics is often colder than the math of ballistics. A soldier can be replaced in weeks. but a specialized manufacturing supply chain for military-grade fiber optics takes months to rebuild. By 0430 hours, the fires at the Rubicon facility were visible to satellite constellations orbiting 200 kilometers above the Earth. The thermal bloom was so intense that it saturated the sensors of commercial monitoring services, flagging the site as a catastrophic industrial accident. But on the ground, the reality was strictly military. The surviving Russian elements in the sector were now operating in a state of severe information paralysis. The Rubicon Center had acted as a central node for processing the high-bandwidth video feeds that fiber optic drones provide. These unjammable feeds were the eyes of the Russian artillery in the Kursk sector, allowing for real-time adjustments of fire with perfect clarity. When the center vanished, those screens went black. Artillery batteries that relied on the Rubicon's feeds were suddenly blind, firing at outdated coordinates or ceasing fire entirely to conserve ammunition. The Ukrainian commanders had anticipated this blindness. Within minutes of the strike, Ukrainian assault brigades on the Zero Line began localized probing attacks, exploiting the sudden lack of enemy reconnaissance. They moved through sectors that had been lethal kill zones only hours before, knowing that the all-seeing eye of the fiber optic drone was currently blinking smoke and debris. The psychological impact of the strike rippled through the Russian drone operator community with the force of a physical blow. For 2 years, drone operators on both sides had enjoyed a relative degree of safety, launching their birds from hidden basements or dugouts kilometers behind the contact line. But the Rubicon operators were different. They were the elite, the untouchables, who believed their technology placed them above the grim calculus of the trenches. The liquidation of their headquarters shattered this caste system. It demonstrated that no amount of technological sophistication can protect a unit that ignores the fundamentals of operational security. The intercepts picked up by Ukrainian intelligence in the following days painted a picture of deep paranoia. Russian drone teams began refusing to deploy from established positions, fearing that any transmission or any thermal signature would summon another tungsten rain. They spent more time digging and hiding than flying. The efficiency of the Russian drone operations in the sector plummeted by an estimated 40% in the week following the strike, not because of a lack of equipment, but because of a surplus of fear. The operators had realized that while their drones might be invisible to jammers, their bodies were very visible to rockets. This event marked the end of the experimental phase of fiber optic warfare and the beginning of its industrial attrition phase. The Rubicon unit had been a proof of concept, a specialized scalpel designed to cut through Western electronic defenses. Ukraine's response was to use a sledgehammer. The strike proved that the counter to a high-tech, unjammable weapon isn't necessarily a better jammer. It is often just better intelligence and a bigger explosive. The cat-and-mouse game had evolved. It was no longer about hacking the signal. It was about hunting the logistics. Ukrainian special forces began prioritizing the identification of the specialized transport vans required to move the heavy fiber optic ground stations. These vehicles, often modified civilian trucks with reinforced suspensions to carry the heavy spools, became high-priority targets for FPV kamikaze drones. The war had shifted from an electronic duel in the ether to a physical hunt on the roads. Every fiber optic drone launch requires a physical tether to the launch point, a literal line leading back to the operator. The Ukrainians began using high-resolution agricultural drones to scan the tree lines for these thin strands of glass, following the breadcrumbs back to the source. As the sun rose over the smoking ruins of the Rubicon Center on February 3rd, the landscape of the drone war had fundamentally changed. The strike didn't end the threat of fiber optic drones. The technology is too effective to be abandoned, but it ended the impunity of their operators. It forced the Russians to disperse their assets, breaking up the concentrated expertise of the Rubicon unit into smaller, less effective cells. It increased the friction of war for the invader, forcing them to expend precious time and resources on survival rather than offense. The Rubicon unit had crossed a line in technological warfare, introducing a weapon that bypassed the rules of the electronic spectrum. In response, Ukraine reminded them of the oldest rule of warfare: if you can be found, you can be killed. The elite status of the unit, their specialized patches, and their arrogance were buried under tons of concrete and twisted rebar. At 0445 hours, a solitary Kamaz Typhoon K armored transport roared out of the tree line onto the P200 highway, its engine straining against the weight of improvised armor. Inside sat the surviving senior engineers of the Rubicon unit, clutching hard drives filled with terabytes of flight data and guidance algorithms. They were running for the deeper rear, believing speed was their armor. But speed is a relative concept when the hunter is loitering 3 kilometers above. A Ukrainian Vampire-heavy drone tracked the heat plume of the Typhoon's diesel exhaust, acting as a spotter for a ground team from the 73rd Maritime Center hiding in a drainage ditch 2 kilometers down the road. The operators watched the truck grow in their sights through the optical scope of a Stugna P anti-tank guided missile launcher. The Typhoon was designed to withstand mines, but not a 130mm tandem charge warhead impacting the engine block. The math of the ambush was brutal. A $2 million vehicle carrying $10 million of intellectual property was about to be deleted by a $20,000 missile fired by a carpenter from Lviv. The impact was catastrophic. The Stugna missile didn't just disable the vehicle, it turned the troop compartment into a pressure cooker of spalling metal and overpressure. The driver, blinded by the sudden detonation, jerked the wheel, sending the 20-ton beast rolling into the frozen mud. The fight wasn't over. 2 survivors, dazed and concussed, stumbled from the rear hatch, dragging the last functional fiber optic control station. In a desperate bid to clear the ambush, they attempted to deploy a drone, their trembling fingers fumbling with the delicate glass spool. It was muscle memory. When under fire, launch the bird. But fiber optic drones require stillness to launch, a stable platform to ensure the glass thread doesn't snap. As the operator tried to stabilize the unit, the Vampire drone overhead dropped a single fragmentation munition. It wasn't a precision strike calculated by a supercomputer. It was gravity and timing. The bomb fell silently, landing directly between the 2 men. The explosion shredded the control station, and the spool of fiber optic cable unspooled in the blast, glittering like a spiderweb across the blackened snow. The surviving Russian units in the area dug deeper, stayed quieter, and looked up at the sky with a renewed sense of dread, knowing that the rules of the game had changed again. The invincible Rubicon had been crossed, and on the other side, they found only fire. At 3:14 a.m. local time, the air defense radar at the Ryazan oil refinery registered a ghost. The operator in the command booth blinked at his screen, dismissing the flicker as a bird flock or a thermal anomaly from the cracking towers. The Ryazan plant sits roughly 180 kilometers southeast of Moscow, deep within what Russian command considered the safe zone. The logic was simple. To reach Ryazan, an object would have to traverse over 500 kilometers of the most densely defended airspace on the planet. It would have to bypass the S-400 batteries guarding the border, slip through the electronic warfare belt around the capital, and evade the point defense systems specifically tasked with shielding strategic energy infrastructure. The math said it was impossible, but the math was wrong. The flicker on the screen wasn't a bird. It was a Liuchi long-range attack drone, a low-cost aluminum bird powered by a 50-horsepower Rotax engine, humming along at 150 kilometers per hour just 30 meters above the tree line. The drone didn't care about the S-400 batteries because it was flying below their radar horizon. It didn't care about the electronic warfare jamming because its terminal guidance relied on deep learning optical navigation, matching the silhouette of the refinery's distillation tower against an internal database of satellite imagery. The operator realized his mistake exactly 4 seconds too late. The physics of a crude oil refinery are unforgiving. The entire facility operates as a single, pressurized organism, designed to turn raw crude into diesel and jet fuel. At the heart of this organism is the primary distillation unit, a steel column standing 50 meters tall where crude oil is heated to 370 degrees Celsius. If you take that column offline, the entire plant stops. You cannot just route the oil somewhere else. It is the bottleneck. Ukrainian intelligence understood this engineering constraint better than the Russians understood their own defense. They didn't target the storage tanks, which look dramatic when they explode but are easily replaced. They targeted the cracking columns. At 3:14 and 12 seconds, the Liuchi drone slammed into the upper third of the AVT-6 distillation unit. The 50-kilogram warhead didn't just dent the steel. The shaped charge punched through the thermal cladding and detonated inside the vapor chamber. The explosion tore the column open, depressurizing hundreds of tons of superheated hydrocarbons in a fraction of a second. The resulting fireball wasn't just an explosion, it was a catastrophic failure of the plant's vascular system. The operator in the control booth watched his pressure gauges drop to zero as the night sky outside turned orange. Ryazan, the third largest refinery in Russia, was effectively dead. What happened at Ryazan was not an isolated incident, but the opening move of a synchronized campaign that would rewrite the economics of the war. Throughout the summer and autumn of 2025, Ukrainian planners systematically dismantled the Russian fuel network using a weapon that cost less than a mid-range family sedan. The strategic logic was ruthless. A modern oil refinery costs billions of dollars to build and takes years to repair. especially when sanctions blocked the import of Western components. The drone that destroyed it costs roughly $35,000. This is the asymmetry of modern warfare. Russia was spending millions of dollars on interceptor missiles to shoot down cheap drones. And when they missed, they lost infrastructure worth hundreds of millions. In the weeks following the Ryazan strike, similar ghosts appeared on radar screens across the chaotic industrial heartland. At Novokuybishevsk, nearly 900 kilometers from the Ukrainian border, the scenario repeated itself with terrifying precision. The facility's operators believed they were out of range. They relied on the simple arithmetic of distance. But Ukraine had extended the range of its one-way attack drones to over 1,000 kilometers, turning the entirety of European Russia into a target-rich environment. The strike on Novokuybishevsk revealed a glaring gap in Russian air defense architecture. Systems like the Pantsir S-1 are designed to protect specific points, creating a dome of protection roughly 20 kilometers wide. But Russia has dozens of refineries, hundreds of depots, and thousands of kilometers of pipeline. There are simply not enough Pantsir systems in the inventory to cover everything. To protect Novokuybishevsk, the Russian military would have to pull air defense assets from the front lines in Ukraine, leaving their tanks and artillery vulnerable to HIMARS and Storm Shadow missiles. It was a dilemma with no correct answer. If they protected the refineries, the front line would collapse. If they protected the front line, the refineries would burn. On that Tuesday morning in late summer, the decision was made for them. Two drones approached the Novokuybishevsk plant from the south, utilizing the Volga River as a navigational handrail to mask their radar signature. The local air defense commander hesitated, unsure if the contacts were friendly traffic or threats. In that hesitation, the first drone struck the catalytic cracker, a specialized unit used to produce high-octane gasoline. The second drone circled back and struck the control center, blinding the facility's ability to manage the fire. The economic impact of taking Novokuybishevsk offline was immediate and severe. This refinery wasn't just making gas for civilian cars, it was a primary supplier of diesel fuel for the Russian military logistics chain. A single tank division consumes up to 250,000 liters of fuel per day during offensive operations. Without that fuel, a T-90 tank is just a 50-ton paperweight. By knocking out the refining capacity at Ryazan and Novokuybishevsk, Ukraine was essentially starving the engines of the war machine hundreds of kilometers before the fuel could even reach the tank nozzles. The math of logistics began to break down. Russia had plenty of crude oil in the ground, but crude oil cannot run a tank engine. It needs to be refined. With the distillation towers essentially turned into twisted scrap metal, Russia was forced to start importing refined gasoline from Belarus and Kazakhstan, a humiliating reversal for a dedicated energy superpower. The Kremlin tried to hide the damage, claiming falling debris caused minor fires, but satellite imagery told a different story. The infrared heat signatures of the cracking towers, which usually glow bright white on thermal cameras, had gone dark. The plants were cold. Then came Volgograd. If Ryazan was a warning and Novokuybishevsk was a tactical blow, the strike on the Volgograd refinery was a masterclass in psychological warfare. Located in the south, Volgograd is a critical hub for supplying the southern front and the occupation forces in Crimea. The refinery produces a significant percentage of the diesel used by the Black Sea Fleet and the mechanized brigades in the Zaporizhia sector. The Russians knew it was a target. They had fortified the airspace with layers of electronic warfare jammers and positioned mobile anti-aircraft gun teams on the rooftops of the tallest distillation towers. They were ready, or so they thought. The Ukrainian attack didn't come from the sky in the way they expected. The drones utilized a complex waypoint navigation system, flying a zigzag pattern that routed them through gaps in the radar coverage mapped out by Western intelligence. They approached the refinery at an altitude of just 15 meters, low enough that the radar waves from the S-300 systems simply passed over them. The gun crews on the roofs heard the lawnmower sound of the engines before they saw the airframes. But by then, the engagement geometry was impossible. You cannot traverse a heavy machine gun fast enough to track a drone flying at 150 kilometers per hour when it is already inside the facility's perimeter. The primary target at Volgograd was the vacuum distillation unit. This specific piece of machinery takes the heavy residue left over from the initial refining process and breaks it down further. It is heavy, specialized, and incredibly difficult to manufacture. When the warhead struck the side of the vacuum tower, it didn't just cause a fire. It compromised the structural integrity of the entire assembly. The tower listed and collapsed, taking with it the network of pipes and pumps that fed the rest of the refinery. In an instant, one of the largest fuel producers in southern Russia was taken off the board. The ripple effects were felt almost immediately at the front lines. Russian logistics officers intercepted over open radio channels began reporting critical shortages of diesel. Convoys of ammunition trucks sat idling in depots, unable to move because their fuel tankers were empty. The strategic paralysis was setting in. The strikes were doing what sanctions had failed to do. They were physically deleting the revenue stream and the logistical backbone of the Russian state. And the cost to Ukraine for this victory was negligible. A handful of drones, a few hundred liters of gasoline, and the time of a few determined engineers. The panic in the Russian energy sector was palpable. Refinery managers began welding anti-drone cages around their remaining distillation towers, a desperate improvisation that offered little real protection against a 500-kilogram-shaped charge. The Ministry of Defense ordered the formation of mobile flak groups, essentially trucks with dual machine guns mounted on the back, to patrol the perimeter of every major energy facility. But the scale of the territory was simply too vast. Russia spans 11 time zones. Its pipeline network is long enough to wrap around the Earth multiple times, trying to defend every inch of that network against a drone that can be launched from the back of a pickup truck is a mathematical impossibility. The Ukrainian strategy relied on this impossibility. They forced the Russians to dilute their defenses, spreading their sophisticated surface-to-air missile systems so thin that they became ineffective everywhere. Every S-400 battery moved to guard a refinery in Siberia was one less battery shooting at F-16 jets over the Donbass. It was a game of trade-offs, and Russia was losing on every exchange. As autumn set in, the campaign intensified. The cooler air improved the density altitude for the drone engines, allowing them to carry slightly heavier payloads or fly slightly longer distances. Ukrainian engineers began experimenting with different warhead types. Instead of just high explosives, they started using thermobaric charges. A thermobaric weapon disperses a cloud of aerosolized fuel before igniting it, creating a massive pressure wave and a vacuum that is particularly devastating in the confined spaces of an industrial plant. When a thermobaric warhead detonated inside the piping maze of the Volgograd refinery, it didn't just break machinery. It twisted the steel infrastructure like wet clay. The repairs would not take weeks. They would take years. The Russian energy minister was forced to announce a ban on gasoline exports to stabilize domestic prices, which had spiked by 40% in a single month. The average Russian citizen, who had largely been insulated from the reality of the war, suddenly found fuel pumps running dry and prices climbing every week. The war had come home, not in the form of soldiers, but in the form of empty gas tanks. But the technical evolution of the drone fleet was perhaps the most alarming development for the Kremlin. Early in the war, drones were simple, remote-controlled aircraft. By the autumn of 2025, the vehicles striking Russian refineries were semi-autonomous robots. They utilized terrain contour matching, a technology once reserved for cruise missiles costing $2 million apiece. The drone used a downward-facing camera to scan the ground and compare it to a stored map, allowing it to navigate without GPS. This made the vast Russian investment in GPS jamming completely irrelevant. The jammers could blast noise on the L-band frequencies all day, but the drone wasn't listening. It was looking at the ground. This leap in technology rendered the electronic warfare curtain, which Russia had spent decades perfecting, obsolete overnight. The drone would fly silently through the jamming zone, identify the thermal signature of the cracking tower, and dive. The first time the Russians realized the jammers weren't working was when the fires started burning at the Tuapse refinery on the Black Sea coast. At 4:12 a.m. local time, the second wave of drones arrived at the Tuapse refinery. This facility, situated on the Black Sea coast, is critical for supplying fuel to Russian forces in southern Ukraine and for export through the Mediterranean. The first drone struck the vacuum flasher, a specialized unit that separates heavy crude oil components under low pressure. The explosion tore a 3-meter hole in the side of the column, causing immediate depressurization. But the real damage came 40 minutes later. Russian emergency crews had just arrived on the scene, deploying foam trucks to contain the blaze, when the second drone appeared. It didn't strike the fire. It struck the main pumping station that feeds crude oil into the furnace. The logic was cruel but effective. By destroying the pumps while the fire crews were distracted, Ukraine ensured that the refinery couldn't just restart once the fire was out. The entire feed system was dead. The pump's massive centrifugal units, custom-built in Germany, are now under strict sanctions. Russia cannot buy replacements. They have to scavenge them from other, less critical refineries, or try to manufacture inferior copies domestically. The downtime for Tuapse went from weeks to months. The cumulative effect of these strikes began to show up in the data. By late September, Russian gasoline production had fallen by 14%. That sounds like a manageable number until you look at the margins. Russia consumes roughly 85% of the gasoline it produces domestically. The remaining 15% is for export, which generates hard currency for the war effort. When production drops by 14%, that export surplus vanishes. Russia stopped exporting gasoline entirely. The Kremlin, desperate to keep domestic prices stable, banned exports for 6 months. But the math of the global market is unforgiving. Without export revenue, the oil companies have less capital to repair the damaged refineries. It becomes a death spiral. A refinery that isn't exporting isn't making money. A refinery that isn't making money can't buy the black market components needed to fix the distillation towers. And a broken distillation tower means even less gasoline next month. The intricate dance of global energy logistics had turned into a stumbling collapse. By October, the shortages hit the agricultural sector. The harvest season in southern Russia relies on fleets of combine harvesters and heavy trucks, all of which run on diesel. But the diesel was gone. It had been diverted to the tanks on the front line or burned up in the refinery fires. Farmers in the Stavropol region reported waiting 3 weeks for fuel deliveries that never arrived. The price of diesel on the wholesale market jumped by 60% in 6 weeks. This is the hidden cost of the drone campaign. It wasn't just about stopping tanks. It was about stopping the tractors that harvest the wheat. If Russia cannot harvest its grain, food prices soar, inflation spikes, and the economic stability that Putin prizes above all else begins to fracture. The Russian central bank was forced to raise interest rates to 21% to combat the inflation caused by rising fuel costs. A 21% interest rate is effectively a ban on economic growth. It means no new businesses, no new mortgages, and no new investments. The drone strikes had achieved an economic effect that billions of dollars in Western sanctions had failed to deliver. The Russian military response was a mixture of desperation and improvisation. They began deploying Panzer systems on top of specially built towers around key refineries, trying to give their radars a better horizon to spot the low-flying drones. But a Panzer system costs roughly $15 million. A tower costs another $200,000, and there are simply too many targets. To defend the Omsk refinery alone, you would need 4 Panzer batteries to cover all approach vectors. That is $60 million of air defense hardware sitting in Siberia, thousands of kilometers from the front. Every Panzer in Omsk is a Panzer that isn't protecting a command post in Donetsk. Ukraine had forced Russia into a game of strategic whack-a-mole. If the Russians moved air defense to the refineries, Ukraine struck the airfields. If they moved it back to the airfields, the refineries burned. The sheer geographical size of Russia, once its greatest defensive asset, had become its greatest liability. You cannot defend 17 million square kilometers with a finite number of surface-to-air missiles. Then came the technological checkmate. In November, reports emerged that Ukraine was using fiber optic guided drones for terminal attacks on refinery infrastructure. These drones unspool a thin fiber optic cable as they fly, maintaining a physical connection to the operator. This means the video feed is unjammable. The control signals are unjammable. The electronic warfare systems that Russia had deployed around its remaining refineries were suddenly useless against a threat that didn't use radio waves. The drone operator could fly the aircraft right up to the distillation column, pick the exact weld seam he wanted to hit, and detonate the warhead with surgical precision. The Russian jammers were blasting static into the ether, but the drone was flying on a hard line. It was a low-tech solution to a high-tech problem, and it worked perfectly. The strike on the Saratov refinery proved the concept. The drone bypassed a dense electronic warfare screen and struck the cracking unit's control valves, causing a shutdown that will last until at least the spring of 2026. If a refinery shuts down in the summer, the oil just sits in the pipes. If it shuts down in the Russian winter, when temperatures drop to minus 30 degrees Celsius, the oil cools, becomes viscous, and eventually turns into a waxy sludge that blocks the pipes. If the water in the cooling systems freezes, the pipes burst. An emergency shutdown in January is catastrophic. The entire facility can be ruined simply by the cold. Ukrainian planners knew this. They timed their late autumn strikes to force shutdowns right as the temperature began to drop. The damage wasn't just the explosion, it was the freeze. At 0314 hours on March 12, 2025, a shift supervisor at the Ryazan oil refinery was pouring his third cup of coffee, completely unaware that a swarm of 35 Ukrainian long-range drones had been tracking toward his facility for the past 4 hours. In exactly 120 seconds, the fractional distillation column outside his window, a critical piece of infrastructure responsible for processing 60,000 barrels of crude oil daily, would cease to be a profitable industrial asset and instead become the world's most expensive candle. The attack force had launched from the Chernihiv region at 2300 hours, navigating through the pitch-black night using a complex series of waypoints designed to exploit the known gaps in Russian radar coverage. This was not a random harassment fire mission. This was a synchronized, multi-vector strike package aimed at the jugular of Moscow's energy economy. The primary weapon of choice for this operation was the Lyuty, a Ukrainian-manufactured strategic drone that looks less like a weapon of war and more like a twin-boom civilian hobby plane, until you realize it carries a 75-kilogram warhead over a range of 1,000 kilometers. Its push-propeller configuration, driven by a reliable 50-horsepower internal combustion engine, pushed the composite airframe through the freezing Russian spring air at a leisurely 150 kilometers per hour. Why fly supersonic when you can fly low, slow, and virtually invisible against the ground clutter? The route planning for this raid was a masterclass in geospatial analysis and patience, instead of flying a straight line toward Moscow, which would have taken them directly into the teeth of the formidable ring of S-400 and Panzer air defense batteries protecting the capital. The drone operators chose a path that looked insane on a map. They skirted the border of Belarus, dipped low over the winding river valleys of the Smolensk region, and used the dense forests as a natural radar shield. At an altitude of less than 50 meters, the drones were effectively hiding in the electronic shadow of the terrain. The Russian radar operators, sitting in their warm command trucks, scanning for high-altitude bombers or ballistic missiles, had almost zero chance of spotting a carbon fiber object with the radar cross-section of a large pigeon skimming the treetops. The drone's onboard navigation system was equally sophisticated. It did not rely solely on satellite positioning, which the Russians were known to jam heavily around major cities. Instead, it utilized a form of terrain contour matching, comparing the physical landscape below with a stored digital map, ensuring that even if the GPS signal turned into garbage, the drone still knew exactly where it was within 3 meters. By 0320, the lead elements of the drone swarm had reached the terminal phase of their flight, a point of no return where stealth is traded for terminal accuracy. The target was the atmospheric distillation unit, specifically the primary column where crude oil is heated to 350 degrees Celsius to separate it into various fuel products. To an engineer, this is the heart of the refinery. Destroy the column, and the entire plant shuts down for 6 to 18 months while a custom-built replacement is manufactured. The economics of this strike are brutal enough to make an accountant weep. The Lyuty drone costs roughly $50,000 to produce. The distillation column it was targeting represents an investment of roughly $150 million, not counting the $500 million in lost revenue from the ensuing downtime. That is a return on investment of 300,000%, achieved in the blink of an eye. As the first drone began its shallow dive toward the lit-up industrial complex, the refinery's local defense systems finally woke up. A localized GPS spoofer kicked in, broadcasting a signal telling the drone it was actually flying over an airport 20 kilometers away. This is where the engineering arms race truly gets interesting. In the early days of the war, that GPS spoofing would have sent the drone veering harmlessly into a field, but the Ukrainian engineers had upgraded the guidance logic with what is known as terminal optical correlation. As the GPS signal drifted into nonsense, the drone's nose camera activated, snapping 30 frames per second of the approaching skyline. The onboard computer compared these high-contrast images of the refinery's distinctive thermal and visual signature against a preloaded target library. It saw the tall, thin, vertical structure of the distillation tower, recognized it as the priority target, and locked in the flight path using pure geometry. It stopped listening to the satellites and started flying with its eyes. At 0322, the shift supervisor inside the control room noticed a sudden anomaly on the perimeter security feeds, a fast-moving shadow that did not belong there. He reached for the emergency shutdown button, a desperate attempt to cut the flow of flammable hydrocarbons. But physics is rarely that forgiving. The first drone slammed into the midpoint of the distillation column at a velocity of 180 kilometers per hour. The impact fused the kinetic energy of the drone with the chemical potential of the target in a catastrophic release of energy. The 75-kilogram warhead, likely a thermobaric or high-explosive fragmentation mix, detonated instantly upon contact with the steel skin of the tower. But the real damage came a split second later. The explosion ruptured the pressurized vessel, releasing superheated crude oil vapor into the oxygen-rich atmosphere. When that vapor cloud met the ignition source of the burning warhead, it created a massive secondary fuel-air explosion that was visible from 20 kilometers away. The shockwave shattered windows in the administration building 400 meters away, but the thermal effects were far worse. The structural steel supports of the tower, suddenly subjected to temperatures exceeding 1,200 degrees Celsius, began to lose their tensile strength. Within minutes, the massive steel column began to list to the side, threatening to collapse onto the adjacent piping racks and turn a single disaster into a chain reaction of industrial destruction. And this was just the first hit. There were still 34 drones in the air, and they were not all aiming for the same pipe. Meanwhile, on the outskirts of Moscow, near the Ramenskoye district, a Russian Pantsir I air defense crew was frantically trying to track multiple low-slow targets appearing on their scope. The Pantsir is a formidable system, combining rapid-fire 30mm cannons with 12 supersonic surface-to-air missiles. On paper, it is designed exactly for this scenario. But in practice, the system was being overwhelmed by the sheer volume of the attack. The radar computer was trying to process 12 different tracks simultaneously, all moving at different vectors. The operator had to make split-second decisions on which target to prioritize. Do you shoot the one heading for the electrical substation or the one heading for the aviation plant? He locked onto a drone approaching from the southwest and fired a missile. The missile, accelerating to Mach 3 in seconds, intercepted the drone 3 kilometers out, turning it into a cloud of fiberglass confetti. A cheer went up in the cabin, but their celebration was premature. They had expended a missile costing $200,000 to destroy a drone worth $50,000. And while they were reloading, 3 more drones slipped through the engagement envelope, flying below the radar horizon of the system. The second wave of drones was targeting something even more sensitive than oil: the microelectronics and optics factories that supply the Russian military-industrial complex. One specific target was a facility in the Tomilino district known for producing specialized optical coatings for tank sights and missile seekers. This was a precision strike in the truest sense. Unlike the refinery, where a big explosion anywhere is effective, this target required the drone to hit a specific ventilation shaft or roof section to penetrate the clean rooms below. The drone assigned to this target was carrying a shaped charge warhead, similar to an anti-tank weapon but scaled up for structural demolition. As it approached the urban sprawl of Moscow, the electromagnetic environment became a chaotic soup of jamming signals. The Russians were blasting noise across the 2.4 GHz and 5.8 GHz bands, trying to sever any command link. But these drones were fully autonomous, operating on a fire-and-forget principle that required no human hand on the joystick. They were robots on a suicide mission, driven by algorithms that could not be intimidated or confused by radio static. Back at the Ryazan refinery, the situation had escalated from a fire to a full-blown crisis. The collapse of the primary distillation column had ruptured the feed lines for the secondary cracking unit. Burning crude oil was now flowing through the drainage channels, effectively spreading the fire across the facility faster than the emergency crews could deploy foam. The shift supervisor, now evacuated to a safe distance, watched as a second drone circled overhead. This one behaved differently. It did not dive immediately. It loitered, its engine droning with a terrifying patience. This was a tactical evolution that terrified the emergency responders, the double-tap strike. The drone was waiting for the fire crews to gather, or perhaps waiting for a specific thermal signature to present itself as the fire stripped away the insulation on other tanks. It was a psychological weapon as much as a kinetic one, forcing the firefighters to retreat and let the facility burn rather than risk being caught in the next blast. The economic damage meter was spinning like a slot machine, adding millions of dollars to the bill with every passing minute of unchecked combustion. At 0345, the chaos spread to the civilian sector as the Russian authorities initiated Plan Carpet over Moscow's airspace, a protocol that instantly grounds all commercial flights and clears the sky of anything that is not military. At Domodedovo International Airport, 30 kilometers south of the city center, air traffic controllers watched their radar screens fill with false positives and legitimate threats, unable to distinguish between a passenger jet and a loitering munition. This is the hidden cost of drone warfare that rarely makes the headlines. You do not actually have to hit the airport to shut it down. You just have to fly a $20,000 drone within 10 kilometers of the approach path. The economic ripple effect is immediate and brutal. Diverting 20 heavy wide-body aircraft to alternate airfields burns hundreds of tons of jet fuel, disrupts logistics chains for days, and panics the insurance markets. While the Panzer batteries were busy trying to shoot down the physical drones, the mere presence of the swarm was inflicting millions of dollars in operational losses on the Russian aviation sector every hour. It is a form of economic siege warfare where the attacker spends pennies to force the defender to burn stacks of cash just to maintain a semblance of safety. Meanwhile, a different breed of predator was approaching the Lukoil Nizhneudnefteorg-Zhytomyr refinery, roughly 400 kilometers east of Moscow. This facility processes 17 million tons of oil annually, turning crude into the high-octane gasoline that fuels the Russian war machine. The weapon approaching this target was not the sleek Lyuchi, but a modified aero-pracked A-22 Foxbat, a light sport aircraft converted into an uncrewed aerial vehicle. This monstrosity is the brute force solution to the problem of hardened targets. While the smaller drones carry warheads that can puncture a tank, the converted A-22 carries a payload of nearly 150 kilograms of high explosives. It is essentially a flying car bomb with wings. Flying at 90 kilometers per hour, its Rotax 912 engine screaming like a lawnmower, it relies on sheer audacity rather than stealth. The Russian air defense network is calibrated to detect fast jets or small missiles. A slow-moving, high-radar cross-section plastic plane flying at treetop level creates a cognitive dissonance in the automated targeting logic. Is it a threat? Is it a lost private pilot? By the time the operator decides to fire, the physics of the situation have already decided the outcome. At 0410, the A-22 drone slammed into the refinery's primary fluid catalytic cracking unit. Unlike the earlier strikes which targeted distillation columns, hitting the cracking unit is a stroke of strategic genius. This unit breaks down heavy hydrocarbon molecules into lighter fuels like gasoline and diesel. It operates at extremely high pressures and temperatures, often exceeding 700 degrees Celsius. When the 150-kilogram warhead detonated, it did not just break a pipe. It compromised the structural integrity of a reactor vessel containing hundreds of tons of catalyst and superheated hydrocarbons. The resulting explosion was registered as a magnitude 2.3 seismic event by local monitoring stations. The fireball rose 200 meters into the night sky, a terrifying testament to the energy density of fossil fuels when released uncontrollably. The destruction of this single unit effectively removed 5% of Russia's total gasoline production capacity in a single second. The replacement time for a custom-built catalytic cracker is not measured in weeks, but in years, especially under the crushing weight of international sanctions that block the import of critical Western petrochemical technology. As dawn broke over the Moscow region at 0530, the full scale of the raid became visible to the satellite constellations passing overhead. The Russian Ministry of Defense claimed to have intercepted 58 drones, a statistic that might comfort the general public but terrifies military planners. In a saturation attack, the interception rate is irrelevant. Only the leakage rate matters. If you launch 60 drones and 55 are shot down, but 5 hit critical infrastructure, the mission is a catastrophic success for the attacker. The 5 drones that slipped through the net destroyed assets worth hundreds of millions of dollars and degraded the national energy grid. The Russian air defense crews had expended nearly 120 surface-to-air missiles during the engagement. Each missile costs roughly $200,000 to replace. The total cost of the Ukrainian drone swarm was perhaps $3 million. The cost of the Russian defensive response alone, ignoring the damage to the refineries, was upwards of $24 million. It is an asymmetry that no national budget can sustain indefinitely. You cannot shoot down cheap flying mopeds with gold-plated interceptors forever. The aftermath of the March 12th raid revealed a grim new reality for the Kremlin. The strikes had not just targeted random fuel tanks. They had surgically removed the most complex, hard-to-replace nodes of the energy infrastructure. The attacks targeted the bottlenecks of the process, the distillation towers and cracking units, rather than the storage tanks. A storage tank is just a steel bucket. You can patch it in a week. A distillation tower is a precision-engineered instrument that requires months of fabrication. By knocking out these nodes, Ukraine effectively turned the crude oil in the ground from a strategic asset into a stranded liability. Russia has plenty of oil, but without these refineries, it cannot turn that oil into the diesel required to move tanks or the jet fuel required to fly bombers. The swarm had proven that the concept of a safe rear area was now a historical fiction. With a range of 1,000 kilometers, the Ukrainian drone program had placed the industrial heart of the enemy on the front line. The final insult to the Russian defense network came not from the explosions, but from the silence that followed. As the fires burned at Ryazan, Kstovo, and Kurishi, the global energy markets reacted with predictable volatility. Gasoline futures spiked by 4.5% in trading, reflecting the uncertainty of supply. But for the engineers assessing the wreckage, the message was clear. The era of immune airspace was over. The combination of commercial electronics, clever coding, and basic aerodynamics had defeated one of the world's most dense air defense environments. The drones had utilized a mix of inertial guidance, terrain following, and terminal optical homing to bypass layers of electronic warfare and kinetic interceptors. They had turned the physics of radar horizons and the economics of missile defense against their creators. As the smoke cleared over the blackened skeletons of the distillation columns, one thing was certain: the swarm would be back, and next time, there would be even more of them. At 0847 hours on February 28, 2022, a satellite sensor orbiting 500 kilometers above the Earth captured an image that would define the opening phase of the largest land war in Europe since 1945. Stretching along the P-02 highway from the Belarusian border toward the outskirts of Kyiv was a mechanized column of Russian heavy armor spanning exactly 40 miles. This massive formation, consisting of roughly 15,000 troops and over 2,000 vehicles, was intended to be the hammer blow that would shatter Ukrainian resistance and seize the capital within 72 hours. But as the lead elements of the 35th Combined Arms Army reached the town of Ivankiv, the math of mechanized warfare began to turn against Moscow in a way their planners never anticipated. The column represented a concentrated mass of roughly 64 kilometers of steel, rubber, and high explosives, but it was also a 40-mile-long liability with a fuel consumption rate that exceeded 10,000 gallons per hour just to maintain idle. Inside the Kremlin, the assumption was a 3-day victory. But on the frozen asphalt of northern Ukraine, the reality was a logistical death trap being set by a handful of specialized defenders. The backbone of this massive invasion force relied on the KAMAZ 4 3114 and Ural 4320 series of logistics trucks, vehicles designed for the rugged terrain of the Siberian steppe, but now failing on the muddy shoulders of the Ukrainian countryside. Each of these trucks features a turbo diesel engine generating roughly 240 horsepower. But their effectiveness is entirely dependent on a complex system of tire pressure regulation and high-quality rubber compounds. Ukrainian intelligence had noted that many of these vehicles were equipped with cheap, poorly maintained tires that had spent years rotting in open-air storage depots. As the convoy faced heavy congestion and was forced to maneuver onto the soft, waterlogged soil known as Rasputitsa, the sidewalls of these tires began to disintegrate under the sheer weight of 60 to 70 tons of equipment. This mechanical failure created a cascading effect where a single stalled truck could block an entire battalion's worth of progress, effectively turning the world's second most powerful military into a 40-mile-long stationary target. The Russians had prepared for a lightning strike, but they had fundamentally failed to account for the physics of friction and the structural integrity of 20-year-old vulcanized rubber. By the morning of March 1, 2022, the situation inside the column had transitioned from a tactical delay to a full-blown humanitarian crisis for the Russian soldiers trapped within it. Intelligence reports and intercepted communications revealed that most units had been deployed with only 3 days of food and water, based on the delusional assumption that the capital would fall before their first resupply was even necessary. As the temperature plummeted to -5 degrees Celsius, the Russian troops found themselves trapped in steel coffins, without the fuel required to run their heaters. A standard T-800 BVM tank consumes roughly 4 to 5 liters of fuel per mile while moving. But even at a standstill, its gas turbine engine requires a constant flow of fuel to maintain electronic systems. With the supply lines at the rear of the 40-mile column failing to push through the congestion, The frontline units were forced to choose between freezing in the dark or abandoning their multi-million-dollar vehicles to forage for food in hostile local villages. This was the moment the Second Army in the world began to realize that their logistics were not just a weakness, but a catastrophic systemic failure that no amount of heavy artillery could solve. While the Russian commanders struggled with their internal failures, a specialized Ukrainian unit known as Aerorozvidka was preparing to turn the static column into a graveyard. This unit, consisting of only 30 soldiers and tech-savvy volunteers, specialized in night operations using modified commercial drones and custom-built octocopters. Operating from the cover of the dense forests surrounding Bucha and Irpin, these operators utilized quad bikes to maintain high mobility, allowing them to strike and vanish before the Russians could even identify the direction of the attack. Their primary weapon was the R-18 octocopter, a heavy-lift drone capable of carrying two RKG-3EM anti-tank grenades modified with 3D printed tail fins for vertical dropping. Each of these grenades contains a shaped charge warhead capable of penetrating 220 millimeters of steel armor, which is more than enough to breach the thin top-deck plating of a Russian supply truck or even a main battle tank. The Aerorozvidka teams didn't just target random vehicles. They performed a forensic analysis of the column to identify the most critical nodes, specifically focusing on the lead vehicles and the fuel tankers that were the lifeblood of the entire mechanized formation. At 02:15 hours on March 2nd, the first precision strikes began near the head of the convoy. Moving silently through the forest on their electric quad bikes, the Ukrainian operators deployed their drones under the cover of complete darkness, utilizing thermal imaging sensors that could detect the heat signatures of Russian engines from over 2 kilometers away. The thermal feeds showed the Russian vehicles as bright white blooms against the cold blue background of the forest, making target acquisition almost effortless for the experienced pilots. The first RKG-3 grenade struck the lead Kamaz fuel truck with mathematical precision, the shaped charge jet traveling at over 25,000 feet per second to ignite the thousands of gallons of diesel fuel within. The resulting explosion didn't just destroy the vehicle, it created a physical barrier of burning wreckage that effectively capped the northern end of the road. With the front of the 40-mile column now paralyzed, the Russian forces were forced into a state of tactical claustrophobia, unable to move forward and increasingly vulnerable to the precision strikes that were now beginning to systematically pick apart their rearguard elements as well. The air above the frozen highway was also contested by the Bayraktar TB2, a Turkish-built medium-altitude long-endurance drone that became the unexpected symbol of Ukrainian resistance during these critical days. The TB2 features a 12-meter wingspan and is powered by a 100-horsepower Rotax 912 IS engine, allowing it to loiter at altitudes of up to 18,000 feet for over 24 hours. More importantly, it is equipped with the Wescam MX-15D electro-optical and infrared imaging system, providing the operators with a high-definition view of the entire 40-mile trap. From their control stations hundreds of kilometers away, the Ukrainian pilots utilized MAML laser-guided smart munitions, which weigh only 22 kilograms but pack a punch capable of obliterating a Buk M2 air defense system or a command and control vehicle. Each MAML bomb utilizes a high-explosive fragmentation or armor-piercing warhead, guided by a semi-active laser seeker that ensures a circular error probable of less than 3 meters. These strikes were not just about physical destruction, they were about psychological warfare, proving to the Russian leadership that their massive armored fist was entirely transparent to modern precision sensors. The geography of the region played a decisive role in tightening the 40-mile trap around the Russian forces. The P-02 highway is bordered by dense forests and the Irpin River, creating a natural funnel that limits any large-scale maneuvering off the main road. Russian doctrine typically relies on wide front advances, but the soft soil and the destruction of the Irpin Bridge by Ukrainian engineers forced the entire 35th Army into a single-file line of death. When the Russian engineers attempted to deploy pontoon bridges to bypass the destroyed crossings, they found themselves under constant surveillance by Ukrainian partisan spotters equipped with encrypted smartphones. These ordinary civilians provided real-time coordinates to Ukrainian artillery units, who utilized Soviet-era D-30 howitzers and modern Grad multiple-launch rocket systems to rain fire on the bridgehead attempts. The math was simple, but brutal. For every bridge the Russians tried to build, the Ukrainians had already pre-calculated the firing solution for their 122mm shells, ensuring that no vehicle would ever cross the river to threaten the heart of Kiev. Inside the command centers of the Russian forces, the operational failure was compounding by the hour as the communication systems began to break down. The Russians had heavily invested in the Azart digital radio system, which was supposed to provide secure, encrypted communications across the entire theater of operations. However, due to a lack of sufficient infrastructure and poor training, many units found that their expensive digital radios couldn't connect over the distances required for a 40-mile column. In a desperate attempt to maintain command, Russian officers began utilizing unencrypted civilian-grade radios and even local mobile networks, which the Ukrainian signals intelligence units were all too happy to monitor. This allowed the defenders to identify the exact location of high-value targets, including generals and senior colonels who were forced to move toward the front of the congestion to resolve the traffic jams personally. The result was a devastating loss of leadership, as Ukrainian snipers and drone teams utilized this intelligence to eliminate the very people who were supposed to be fixing the logistical nightmare, leaving the rank-and-file soldiers without direction in the middle of a frozen wasteland. By March 4th, the 40-mile column had effectively ceased to be a functioning military unit and had instead become a massive, linear warehouse of abandoned equipment. Satellite imagery showed thousands of vehicles parked bumper to bumper, with many troops now visible outside their tanks, huddling around open fires made from scavenged wood and debris. The elite 4th Guards Tank Division, which was supposed to lead the assault on the city center, was instead reduced to guarding empty fuel trucks and hoping for a resupply that would never arrive. The Ukrainian defense had successfully frozen the invasion in place, not through a massive counteroffensive, but through the surgical application of logistics as a weapon of war. They had identified the 3 pillars of modern mechanized warfare: fuel, food, and movement, and systematically kicked them out from under the Russian army. The 40-mile traffic jam was the first undeniable visual proof that the supposedly invincible Russian military was built on a foundation of systemic corruption and operational incompetence that could be dismantled by a few dozen operators on quad bikes. The economic cost of this single operational failure was staggering, with analysts estimating the loss of equipment and fuel to be in the hundreds of millions of dollars. But the true price was paid in the loss of strategic momentum, as the world watched the superpower narrative of the Russian Federation dissolve in real time on social media. Each destroyed tank, worth over $3 million, was being filmed by local teenagers on their phones and uploaded to the internet before the smoke had even cleared. This transparency created a global shift in perception, as Western nations saw that Ukraine wasn't just surviving, but was actively humiliating the invaders through superior tactical flexibility and technological integration. The 40-mile trap was more than just a military victory. It was a proof of concept for a new way of fighting, where small, decentralized units utilizing high-tech sensors could paralyze a massive, centralized force that was still operating on 20th century doctrine. As the sun set on March 5th, the frozen army north of Kyiv was no longer an invasion force. It was a warning to any nation that believes sheer mass can overcome the precision and determination of a modern defender. As the sun rose on March 5, 2022, the 40-mile column had transitioned from a logistical headache into a full-scale mechanical cardiac arrest. The sheer density of the vehicles meant that the heat signatures detected by Ukrainian sensors were no longer individual trucks, but a continuous, pulsing ribbon of infrared energy stretching through the northern forests. A critical, but often ignored factor in this stagnation was the physical chemistry of diesel fuel in sub-zero temperatures. Russian military-grade diesel is treated with additives to prevent waxing, but when an engine idles for 72 consecutive hours, carbon deposits begin to choke the fuel injectors and exhaust manifolds. The T-72B3 tanks, which form the iron core of the Russian armored spearhead, utilize the V92S2F diesel engine, a 12-cylinder beast that generates 1,130 horsepower. However, at a standstill in -5-degree weather, these engines become massive heat sinks that drain the vehicle's batteries and consume fuel at a rate of roughly 10 gallons per hour just to keep the crew from freezing. The paralysis of the column reached its terminal phase in the narrow residential streets of Bucha and Irpin, where the geography of the Kyiv suburbs acted as a high-pressure valve that simply refused to open. On Vokzalna Street in Bucha, a single Ukrainian ambush transformed a tactical advance into a graveyard of scorched aluminum and twisted steel. Utilizing the British-made NLAW, or Next-Generation Light Anti-Tank Weapon, Ukrainian defenders engaged the column from the upper floors of apartment buildings at ranges of less than 100 meters. The NLAW's overfly top attack mode uses a magnetic sensor to detect the mass of a tank, detonating its shaped charge warhead directly over the thin roof armor. This creates a vertical jet of molten copper that bypasses the explosive reactive armor blocks on the tank's sides. In a matter of minutes, the lead 30 vehicles of a Russian VDV airborne unit were reduced to smoldering husks, physically blocking the road and trapping hundreds of following vehicles in a kill zone that was only 10 meters wide. While the kinetic strikes captured the headlines, the silent killer of the 40-mile column was the phenomenon known as Rasputitsa, or the season of the mud. As the spring thaw began to saturate the Ukrainian soil, the moisture content in the earth increased to over 40%, turning the seemingly solid fields into a viscous, non-Newtonian fluid. The Russian heavy equipment, particularly the MESITAS, self-propelled howitzers weighing over 42 tons, exerts a ground pressure that far exceeds the load-bearing capacity of waterlogged silt. When a driver attempted to steer off the paved P02 highway to bypass a wreck, the massive tracks would instantly dig into the mire, burying the vehicle up to its chassis. Intercepted radio traffic revealed that Russian recovery crews were overwhelmed, with the heavy-duty BREM, one armored recovery vehicles themselves becoming stuck while trying to winching out stranded tanks. This created a geometric nightmare where the only path forward was a single strip of asphalt already choked with the debris of previous failed attempts. The technological disparity within the column was further highlighted by the complete failure of Russian electronic warfare units to suppress the Ukrainian drone artillery loop. On paper, the Russian Krasuka 4 system is designed to jam satellite signals and drone control frequencies across a 300-kilometer radius. However, the decentralized nature of the Ukrainian defense meant that for every frequency the Russians jammed, the defenders simply switched to another off-the-shelf commercial band or utilized hardwired landlines for communication. The Ukrainian operators used the GIS-ARTA software, often described as an Uber for artillery, which processed target coordinates from drones and partisans in less than 30 seconds. This digital ecosystem allowed a single D-30 howitzer battery, located 15 kilometers away, to receive a precise GPS coordinate, fire a 122mm shell, and adjust its aim based on real-time drone feedback. The Russian troops, sitting in their 40-mile traffic jam, had no way to counter this invisible, high-speed kill chain that treated their massive formation like a target on a firing range. By the end of the first week of March, the human element of the Russian invasion force began to disintegrate under the weight of logistical neglect. Intercepted phone calls home revealed soldiers who had not eaten a hot meal in 5 days and were forced to drink radiator water or melt snow to survive. The standard Russian individual first aid kits and field rations, many of which were discovered to have expired in 2015, provided no protection against the creeping onset of trench foot and hypothermia. This physical decay led to a widespread abandonment of high-value military assets, as crews simply walked away from their vehicles in search of warmth and food. The strategic cost of the 40-mile failure was felt far beyond the outskirts of Kyiv, as it forced a total recalibration of the Kremlin's war aims. The original plan to seize the capital and install a puppet government had been predicated on the speed of the mechanized advance, but the column's collapse meant that the window of opportunity had slammed shut. Every hour the column sat stationary, the Ukrainian government was able to receive more Western shipments of Javelin missiles and Starlink terminals, further hardening the defenses. The economic math was a disaster for Moscow. They had committed roughly 30% of their total combat-ready ground forces to a single axis of attack, only to have them neutralized by a force that cost less than 1% of their annual defense budget. The 40-mile trap demonstrated that in the era of high-definition satellite surveillance and precision-guided man-portable weapons, massed armor is not a guarantee of victory, but a massive logistical target that requires a level of organizational competence the Russian military simply did not possess. February 21, 2026. At 0300 hours local time, the night shift supervisor at the Votkinsk machine building plant in the Udmurt Republic poured his coffee, expecting a completely routine morning. This massive state-owned facility was the beating heart of the Russian strategic deterrence program, responsible for churning out Iskander ballistic missiles and nuclear-capable intercontinental ballistic missiles. Situated more than 1,400 kilometers from the Ukrainian border, the plant was considered an absolute sanctuary by military planners in Moscow. It was geographically insulated by multiple layers of integrated air defense systems, early warning radars, and sheer continental distance. The assembly workers inside believed they were completely untouchable, building weapons of destruction far beyond the reach of any conventional adversary. What they absolutely did not know was that their assumed immunity had an expiration date, and the countdown had already begun 2 hours earlier. At 01:15 hours, deep inside Ukrainian territory, a battery of domestically produced Flamingo cruise missiles roared off their concealed mobile launchers, piercing the night sky before immediately pitching down to tree level. The Flamingo was a heavily guarded secret, a low, observable, autonomous strike weapon designed specifically for extreme range penetration. Unlike traditional drones that rely on easily jammed satellite navigation, the Flamingo utilizes an inertial navigation system paired with optical terrain contour matching. It functions exactly like a pilot flying visually by comparing the rivers, hills, and highways below with a high-resolution map stored in its memory. This makes the weapon virtually immune to electronic warfare. Once it drops to an altitude of 30 meters, it vanishes from long-range radar, becoming a ghost in the machine programmed to thread the needle entirely through hostile Russian airspace without emitting a single radio frequency signal. The math governing this strike was incredibly brutal and unforgiving. To cover 1,400 kilometers at a cruising speed of 850 kilometers per hour, the Flamingo missiles had to survive more than 100 minutes inside highly contested hostile airspace. They crossed the border in a dispersed formation, immediately entering the engagement envelope of multiple Russian surface-to-air missile batteries. A radar operator in the Belgorod region stared at his glowing displays, watching the sweeping green line of his search radar. His system was calibrated to detect high-altitude fighters and massive ballistic threats falling from the stratosphere. Searching for a composite material cruise missile hugging the Earth at 30 meters is like trying to spot a single black bird flying low over a dark forest at midnight. The operator saw nothing but ground clutter, completely unaware that multiple warheads had just slipped past his designated defensive sector. This audacious penetration was unfolding against a backdrop of hardened geopolitical gridlock. Just days earlier, the third round of peace negotiations brokered by the United States had concluded in Switzerland. Like the previous diplomatic sessions held in Abu Dhabi, which officials had desperately labeled as constructive, the talks ended with absolutely no breakthrough. As the fourth anniversary of the conflict rapidly approached, the Ukrainian military was demonstrating a severe shift in strategic doctrine. If diplomatic channels could not secure their cities from relentless bombardment, they would systematically dismantle the industrial nodes, sustaining the aggression from the inside out. The strike package was not just a tactical maneuver, it was a physical message delivered at 850 kilometers per hour, proving that the geographical buffer Russia relied upon to protect its military-industrial complex simply did not exist anymore in this new era of warfare. As the flight path pushed deeper into the Russian interior, the Ukrainian strike package began to execute a complex separation maneuver. A secondary detachment of munitions banked sharply to the southeast, adjusting their vector toward the Samara region. Their designated target was a massive gas processing plant, a critical node in the energy infrastructure fueling the Russian war machine. Coordinating a simultaneous split strike deep inside enemy territory without active data links requires flawless pre-flight programming. The navigational computers had to calculate wind drift, fuel consumption, and terrain masking for two completely different geographical routes. The main element of Flamingo missiles maintained their primary heading toward Votkinsk, their optical sensors constantly matching the snowy terrain below with their internal maps, making micro-course corrections in complete radio silence to ensure they stayed perfectly hidden within the radar shadows of the Ural foothills. The regional air traffic control network showed zero anomalies as the weapons pushed further east. Commercial flights were actively rerouted around known military zones, but the low-altitude airspace remained entirely unmonitored by civilian authorities. The Flamingo missiles were now 800 kilometers deep, operating far past the limits of what Russian generals believed was theoretically possible for a domestically produced Ukrainian system. They were flying entirely emission silent. Their cold airframes radiated very little heat, and their radar cross-sections were equivalent to small birds. The vast Russian integrated air defense network, designed to repel massive formations of strategic bombers, was fundamentally ill-equipped to handle a swarm of autonomous terrain-hugging cruise missiles that refused to broadcast any signals. Back in the Udmurt Republic, the local air defense network finally detected an anomaly that shattered the quiet morning. At 0310 hours, a short-range Panzer battery guarding the Vodkinsk facility picked up intermittent contacts on its search radar. The signatures were incredibly faint, popping up and disappearing behind the local topography, closing in at a truly terrifying speed. The Panzer system is an incredibly capable point defense platform, armed with twin 30mm autocannons and surface-to-air missiles, but it requires a stable track to compute a firing solution. Against actual cruise missiles flying deliberately in the clutter, it was struggling immensely. The operator stared at his display as the fire control solution flickered wildly. Lock acquired, lock lost, lock degraded. He was trying to catch a bullet in the dark, and the targets were intentionally utilizing the factory's surrounding hills to mask their final, devastating approach vector. The Panzer commander had mere seconds to process the geometry of the incoming threat, and the math was entirely against him. The contacts were bearing down on the missile assembly buildings from multiple vectors, saturating his defensive perimeter. He initiated the firing sequence, but acquiring a continuous tracking lock on a terrain-hugging composite missile moving at over 200 meters per second proved nearly impossible. He had one system, two guns, and multiple targets closing in simultaneously. The guns can only point in one direction at a time. Slewing from one target to another takes 2 seconds, and acquiring a stable firing solution takes another 1.5 seconds. A burst sufficient to ensure destruction requires 3 seconds of sustained fire. The total engagement cycle of 6.5 seconds per target meant he physically did not have enough time to shoot down the entire swarm before they crossed the minimum engagement threshold of his weapon system. The facility that built the very weapons terrorizing Ukrainian cities was now staring down the barrel of its own destruction. The first Flamingo missile breached the final defensive ring, its onboard targeting camera identifying the unique thermal and structural signature of the primary manufacturing hall. The onboard computer cross referenced the live feed with its stored imagery, confirming the target with absolute mathematical certainty. The Panzer commander watched his radar screen helplessly as the first contact merged with the exact coordinates of the state-owned factory. There was no time to issue an evacuation order, no time to sound the alarms, and absolutely no way to stop the kinetic energy about to be unleashed. The assembly workers, who had started their shift believing they were protected by 1,400 kilometers of impenetrable Russian airspace, were about to discover that distance was no longer a shield against the technological evolution of modern war. At 0311 hours, the Panzer operator inside the Vodkinsk defensive perimeter realized his complete tracking failure. The twin 30mm autocannons were sweeping the dark sky, burning through hundreds of rounds of high-explosive incendiary ammunition in blind, desperate bursts. But shooting at a ghost creates a mathematical impossibility. The Flamingo missiles were flying at an altitude of just 30 meters, using the massive factory buildings themselves as physical shields against the engagement radar. Every time the system attempted to establish a continuous lock, the incoming contact would dip behind a reinforced concrete structure, instantly breaking the radar return. The commander had exactly 12 seconds before the primary target was reached, and he was completely out of options. He watched his digital display as the faint red icons representing the Ukrainian weapons continuously slipped through his designated kill zones without taking any damage. While the air defense crews in the Udmurt Republic were engaged in a futile battle against invisible targets, the secondary detachment of the strike package was executing its terminal dive over the Samara region. These specialized munitions had navigated hundreds of additional kilometers, utilizing the same terrain masking and emissions silent flight profiles to completely evade detection by regional air traffic control networks. Their objective was a massive gas processing plant, a facility fundamentally critical to refining the energy resources that financially and logistically sustain the Russian armed forces on the front lines. The navigational computers inside these secondary missiles had calculated wind drift and fuel consumption perfectly, ensuring they arrived at their designated target window simultaneously with the primary Vodkinsk strike. The Russian command structure was facing a coordinated multi-vector strategic attack. This highly sophisticated double strike arrived at a highly critical moment on the international stage, perfectly timed just days after highly anticipated diplomatic negotiations completely collapsed. Officials representing Moscow and Kyiv had recently concluded their third round of intensive peace talks in Switzerland, a high-stakes summit heavily brokered by the United States government. Following earlier sessions held in Abu Dhabi that international diplomats had desperately tried to frame as constructive, this latest round yielded absolutely zero tangible progress. With the fourth anniversary of the grinding conflict rapidly approaching, the battlefield reality was completely detached from the diplomatic posturing. The Ukrainian military leadership recognized that sitting at a negotiating table without overwhelming leverage was entirely futile. If the Russian government would not halt its offensive operations through diplomacy, Ukraine would systematically dismantle them. At 03:15 hours, the Samara detachment struck the vulnerable distillation columns and storage infrastructure of the gas processing plant. The resulting inferno sent towering flames hundreds of meters into the freezing air, immediately triggering automated emergency protocols across the regional energy grid. In a desperate attempt to secure the airspace and prevent further penetrations, the Russian military command immediately ordered the temporary closure of several commercial airports throughout the surrounding regions. Grounding civilian aviation was a stark public admission that their integrated air defense network had been critically compromised by weapons launched over 1,400 kilometers away. The sanctuary of the deep Russian interior had been decisively shattered by a nation they believed possessed no long-range strike capability. But the most devastating blow of the morning was still seconds away from landing. Back in the Udmurt Republic, the lead Flamingo missile initiated its final attack geometry. The onboard computer cross-referenced the live optical feed with its stored imagery, confirming the target with absolute mathematical certainty. It recognized the precise structural dimensions of the Votkinsk machine-building plant, specifically identifying the primary manufacturing hall where the highly classified Iskander ballistic missiles and nuclear-capable intercontinental ballistic missiles were actively being assembled. The missile pitched down into a steep, unrecoverable dive, accelerating toward the reinforced roof of the facility. The Pantsir commander stared at his radar screen in utter disbelief as the contact merged perfectly with the center mass of the state-owned factory. There was absolutely no time to issue an evacuation order, no time to sound the alarms, and no way to stop the kinetic energy about to be unleashed upon the unsuspecting workers. The kinetic energy of the impact was immediately followed by the detonation of the high-explosive fragmentation warhead, punching a massive hole directly through the assembly hall roof. For a fraction of a second, nothing happened. Then the highly volatile rocket propellant and sensitive missile components stored on the factory floor violently cooked off in a cascading chain reaction. Residents across Votkinsk captured unprecedented footage of the blast wave, which completely blew out windows in residential blocks kilometers away. Thick pillars of black smoke rose ominously as local officials, including the regional head, took to the Telegram messaging platform to confirm the unprecedented drone attack. The Telegram news channel Astra quickly corroborated that the state-owned ballistic missile plant was the primary target. The factory that built the weapons to destroy Ukraine was now burning to the ground, exactly 1,400 kilometers from the border. At 03:20 hours, the Regional Air Defense Coordination Center in Yekaterinburg devolved into absolute chaos. The duty officers stared at the integrated tracking displays, watching the catastrophic damage reports flooding in from the Udmurt Republic. The realization of what had just occurred was far more terrifying than the explosion itself. The Flamingo missiles had successfully navigated more than 1,400 kilometers of what was supposed to be the most heavily defended airspace on the entire planet. The mathematical implications were instantly devastating for the Russian High Command. If a domestically produced Ukrainian drone could accurately strike the Votkinsk machine-building plant, then every single military installation, oil refinery, and logistics hub located west of the Ural Mountains was now officially an active target. The geographical sanctuary that Moscow had relied upon for 3 years of relentless warfare had evaporated in exactly 100 minutes. Simultaneously, the situation in the Samara region was rapidly deteriorating into a logistical nightmare. The targeted gas processing plant was a critical node in a massive energy network. As the distillation columns burned uncontrollably, emergency valves automatically shut down pipelines, severing the flow of fuel to military depots hundreds of kilometers away. The economic disparity of the engagement was truly staggering to comprehend. The Ukrainian military had expended a handful of Flamingo missiles, each costing roughly $250,000 to manufacture. In return, they had completely paralyzed an infrastructure node worth hundreds of millions of dollars, while simultaneously halting the production of Iskander ballistic missiles valued at over $3 million per unit at the Votkinsk facility. The return on investment for this precision strike package was completely unprecedented, proving that strategic ingenuity could economically cripple sheer industrial mass. The true strategic victory for Ukraine was not just the physical destruction of the manufacturing halls and refining columns, but the impossible dilemma it forced upon the Russian Ministry of Defense. Before this morning, the vast majority of advanced Russian surface-to-air missile systems, including the highly capable S-400 and Buk M3 batteries, were heavily concentrated along the active front lines to suppress Ukrainian aviation. Now the Kremlin faced a crippling geographical nightmare. Russia spans over 17 million square kilometers. To protect their critical interior infrastructure from low-altitude, terrain-hugging autonomous threats, they would have to physically withdraw hundreds of air defense systems from the combat zone and scatter them across the vast expanse of the motherland. Every single radar dish pulled back to guard a factory in the Udmurt Republic meant one less radar dish tracking Ukrainian movements on the actual battlefield. By 0600 hours, the fires at the Votkinsk machine building plant and the Samara gas facility were still burning out of control, casting a dark shadow over the Russian military-industrial complex. The local workers who survived the initial detonations stood outside the defensive perimeter, watching the absolute destruction of their supposedly untouchable sanctuary. The psychological blow was just as devastating as the physical damage to the assembly lines. For 3 years, the narrative dictated that the deep Russian interior was entirely safe from the consequences of the conflict. The Flamingo cruise missiles shattered that illusion at 850 kilometers per hour. The Ukrainian military had completely bypassed the deadlocked diplomatic negotiations in Switzerland, opting instead to deliver a kinetic message that could not be ignored. They had fundamentally rewritten the operational map, proving that in modern warfare, there is absolutely nowhere left to hide. At 0215 hours local time, amidst the freezing darkness of the Siberian taiga, a lone figure trudged through knee-deep snow toward a seemingly insignificant gray metal box beside the Russian railway's main line that forms part of the Trans-Siberian Railway corridor. Frost hung in the air like suspended glass, each breath crystallizing instantly in the sub-zero stillness. The metal cabinet stood half-buried in snowdrift, unremarkable to any passing observer. Just another utility fixture along thousands of kilometers of steel track. But this was an SCB relay cabinet, the central nervous system of Russian military logistics. While the Russian military command focused heavily on protecting ammunition depots and airfields, they largely ignored these thousands of isolated cabinets scattered across the vast expanse of the country. The intruder knew exactly what this box contained and how fragile the entire supply chain truly was. The Russian armed forces rely on the railway network to transport over 60% of all their heavy military equipment, artillery shells, and fuel to the front lines. Unlike highways, which quickly degrade under armored weight, railways distribute mass efficiently over hardened steel rails and reinforced beds. The railway operates on a block signaling system, dividing the massive track into sections measuring roughly 2 to 3 kilometers each. Each relay cabinet controls the traffic lights and automated switches for its specific block, ensuring that no two massive freight trains ever occupy the same section of track simultaneously. In essence, every cabinet functions like a neural node in a continental-scale organism, constantly transmitting, receiving, and calculating the safe choreography of iron giants moving through darkness. Deep inside a regional dispatch center located 400 kilometers away in Novosibirsk, a railway controller watched a massive illuminated board tracking dozens of supply trains. The room hummed softly with electronics, glowing LEDs reflecting off glass panels covered in schematic track diagrams. Train number 472, pulling 70 heavily loaded cars of artillery ammunition and diesel fuel, was currently moving west at a steady speed of 75 kilometers per hour. The controller relied entirely on the electronic telemetry provided by the remote relay cabinets to monitor the safe progression of these high-priority military deliveries. Colored lines shifted across the board, each one representing thousands of tons of moving steel. A single freight train of this massive size weighs approximately 6,000 metric tons, meaning it carries an immense amount of kinetic energy. According to the fundamental laws of physics, stopping that much moving mass requires an enormous amount of friction and distance. Even under ideal conditions, engaging the emergency brakes at full capacity means the train will still slide forward for at least 1.5 kilometers before grinding to a complete and total halt. That distance increases dramatically in freezing weather, when steel wheels meet rails polished by ice crystals. The automated signaling network is meticulously engineered specifically to account for these massive braking distances, keeping the iron giants separated by invisible safety buffers calculated down to the meter. Back in the freezing taiga, the saboteur pried open the door of the relay cabinet using a heavy steel crowbar, the metal hinges groaning briefly before surrendering. Inside, neat rows of electromagnetic relays, copper bus bars, and thick communication cables filled the enclosure like the exposed circuitry of a mechanical brain. Instead of explosives, which were incredibly difficult to smuggle across the country and highly visible to security forces, the operative carried a simple incendiary mixture. They methodically applied a thick layer of thermite paste directly onto the main processing boards and the primary power distribution terminals. Thermite burns at an astonishing temperature of over 2,200 degrees Celsius, which is more than hot enough to effortlessly melt right through copper wiring, thick steel brackets, and sophisticated microchips in a matter of seconds. At exactly 0220 hours, the saboteur ignited the chemical mixture and immediately retreated into the dark tree line. The reaction began silently. No explosion, no dramatic flash, just a blinding white flare that hissed like a cutting torch. Within 30 seconds, the intense thermal reaction completely vaporized the cabinet's internal logic boards, instantly severing the electronic handshake between that specific track block and the regional dispatch headquarters. Molten copper dripped like liquid fire onto the snow below, freezing into twisted metallic sculptures. The moment the relay cabinet's circuitry melted into a pool of glowing slag, the railway's fail-safe protocols automatically engaged across the entire sector. When the central server loses communication with a block cabinet, the system assumes the worst possible scenario and immediately defaults the signals to red to prevent catastrophic collisions. Inside the dimly lit cabin of train number 472, the engineer was staring into the darkness when the trackside signal suddenly flashed from green to a harsh, blinding red. He had exactly 3 seconds to react before the automated safety systems forcefully engaged the train's pneumatic braking sequence. The immense pressure in the brake pipe dropped instantly, forcing the heavy cast iron brake shoes against the steel wheels of all 70 rail cars simultaneously. Sparks showered into the snow as thousands of tons of forward momentum violently fought against the sudden application of mechanical friction. The agonizing screech of metal sliding against metal echoed through the empty forest as the massive locomotive desperately tried to bleed off its kinetic energy. Snow along the track vaporized into steam under the heat of friction, and a plume of metallic smoke trailed behind the skidding train like a wounded beast marking its path. The colossal freight train finally shuddered to a complete stop mere meters before entering the now dead track section, but the tactical damage was already done. In the Novosibirsk dispatch center, a cascade of error warnings flooded the controller's main monitor. Red indicators blinked furiously across a 20-kilometer stretch of track. The destruction of just one relay cabinet essentially blinded the automated traffic management software for a crucial segment of the main logistics artery. Railway doctrine dictates that when electronic signaling fails, operators must switch to an archaic manual method using localized radio relays and paper documentation to authorize the movement of each individual train. This excruciatingly slow process reduces the maximum operational speed of the line from 75 kilometers per hour down to a crawling pace of just 15 kilometers per hour. Dispatchers must confirm block clearance verbally, log it by hand, and coordinate sequential movement with extreme caution. Within 45 minutes, a massive backlog began to form, as 6 additional westbound military supply trains were forced to halt on the tracks behind train number 472. Steel wheels stood frozen against steel rails, engines idling uselessly in the snowbound night. This single $10 thermite charge had just paralyzed the delivery of over 30,000 tons of heavy combat supplies. While the gridlock worsened, the Ukrainian operatives were already initiating the second, far more destructive phase of their silent sabotage campaign. They understood that burning signaling cabinets only caused temporary delays, usually resolved by maintenance crews within 12 to 24 hours. To create a permanent logistical nightmare, They needed to utilize the sheer weight and velocity of the trains as kinetic weapons against the infrastructure itself. 50 kilometers further down the line, another operative stealthily approached a manual switching mechanism near a tight curve in the track. The mathematical formula for derailment relies on the lateral force overcoming the gravitational weight, keeping the train wheels securely seated on the steel rails. If a massive locomotive moving at 60 kilometers per hour suddenly encounters a switch that is only partially thrown, the flanges of the front wheels will forcefully strike the edge of the diverging rail. The immense kinetic energy has absolutely nowhere to go but outward, violently snapping the heavy steel track bolts and tearing the rail completely off the wooden ties. Steel under compression behaves predictably until its yield strength is exceeded, and then it fails catastrophically. The operative carefully unbolted the standard railway lock and wedged a heavy, custom-machined piece of hardened steel between the switch point and the stock rail. This nearly invisible modification forced the heavy switching rail to remain open just 5 centimeters, a tiny gap that would be completely imperceptible to a train engineer hurtling through the darkness but mathematically devastating to the wheel assembly. Frost quickly formed over the altered hardware, concealing the tampering beneath a natural veneer of ice. At 0340 hours, train number 511, carrying 40 flatbed cars loaded with newly refurbished armored personnel carriers, approached the compromised curve. The locomotive's massive headlight cut through the falling snow, illuminating only a narrow tunnel of swirling white. The engineer saw absolutely nothing amiss on the tracks ahead. The train entered the curve at 50 kilometers per hour, generating immense lateral centrifugal forces that pushed thousands of tons of weight heavily against the outer rail. In less than 0.3 of a second, the leading left wheel struck the 5-centimeter gap with the force of a bomb going off, instantly riding up and completely over the steel track head. The massive 120-ton locomotive violently left the rails, its enormous steel wheels grinding directly into the frozen gravel ballast beneath the track bed. Gravity and momentum instantly transformed the train into a highly destructive plow, tearing up wooden ties and concrete sleepers for over 200 meters. As the locomotive aggressively dug into the frozen earth, its rapid deceleration created an unstoppable kinetic shockwave that violently rippled backwards through the remaining 40 flatbed cars. The heavy couplings holding the massive cars together instantly snapped under the immense compressive forces. The first 10 flatbeds carrying newly refurbished armored personnel carriers violently jackknifed, slamming into one another with the force of an artillery barrage. The 60-ton military vehicles snapped their heavy retaining chains like brittle twigs, tumbling off the flatbeds and crashing heavily into the adjacent snow-covered ravine. Twisted steel, splintered timber, and shattered machinery formed a tangled monument to momentum unleashed. Inside the regional dispatch center in Novosibirsk, the nightmare scenario unfolded across the main tracking monitors in real time. The sudden loss of telemetry from train number 511 immediately triggered a catastrophic system-wide alert, completely halting all eastbound and westbound traffic across a 150-kilometer radius. The chief dispatcher frantically attempted to hail the derailed train via the encrypted radio network, but the locomotive's primary communications array had been completely crushed beneath 90 tons of twisted steel. This was not an isolated incident, but rather a highly coordinated logistical decapitation strike. Within a single 3-hour window, the Ukrainian operatives had simultaneously triggered identical sabotage protocols at 7 different strategic choke points across the Trans-Siberian network. The mathematical probability of 7 simultaneous, catastrophic mechanical failures occurring naturally was practically zero. Patterns emerged across the control board like spreading cracks in glass. The Russian Military Logistics Command now faced an impossible mathematical and engineering crisis. Clearing a multi-train derailment deep within the isolated Siberian taiga requires highly specialized heavy recovery cranes, which move strictly by rail. Because the tracks were completely severed on both sides of the massive wreckage, bringing these massive 150-ton railway cranes to the exact crash site became a monumental logistical paradox. To fix the broken track, they desperately needed the trains. But to move the trains, they absolutely needed the unbroken track. Engineering doctrine states that replacing 200 meters of completely shredded track bed in sub-zero winter conditions takes a dedicated crew of 50 men at least 48 hours of uninterrupted labor. Frozen ballast must be excavated, new ties laid precisely, rails aligned to millimeter tolerances, and the entire section reballasted and compacted before safe passage can resume. But with 7 separate derailments blocking the primary logistics arteries simultaneously, the repair timeline rapidly expanded from days into weeks of total operational paralysis. 4,000 kilometers away on the active front lines, The immediate consequences of these silent taiga strikes materialized as a sudden and catastrophic starvation of combat resources. Russian artillery batteries, which routinely consumed over 10,000 heavy shells every single day, suddenly received orders to strictly ration their rapidly depleting ammunition stockpiles. Fuel convoys were delayed, armored units idled, and offensive operations stalled for lack of logistical continuity. The frontline commanders were completely unaware that their desperately needed resupply trains were lying twisted and broken in a freezing Siberian ravine. This brilliantly asymmetrical warfare strategy cost the Ukrainian operatives less than $5,000 in basic thermite, crowbars, and custom-machined steel wedges. In direct contrast, the resulting physical damage to the Russian locomotives, the destroyed armored personnel carriers, and the completely ruined railway infrastructure easily exceeded $150 million in immediate, unrecoverable material losses. The ratio of investment to destruction was staggering. The Russian Interior Ministry fundamentally misunderstood the sheer scale of the vulnerability they were attempting to secure. The Russian railway network spans over 85,000 kilometers of track, passing through some of the most remote and inhospitable terrain on the entire planet. To properly guard every single relay cabinet, switching station, and blind curve against specialized sabotage teams would require deploying over 200,000 dedicated security personnel away from the active front lines. It was a mathematically impossible defensive equation. The saboteurs did not need to win massive bloody battles or destroy heavily guarded fortresses to effectively cripple the Russian war machine. They simply needed to persistently exploit the fragile physics of massive moving objects and the completely undefended electronic nervous system of the railway. In a conflict defined by artillery barrages and armored thrusts, the most devastating blows were sometimes struck silently, in darkness, against unguarded steel boxes half buried in snow. The silent war in the deep taiga continued uninterrupted, bleeding the massive logistics network dry one severed relay at a time. In Novosibirsk, emergency coordination cells worked without pause, drafting contingency routing plans that strained secondary branch lines never designed to handle such concentrated military throughput. Aging tracks groaned under redirected weight, and maintenance crews reported accelerated wear on rails already brittle from extreme cold. Each improvised workaround solved one bottleneck while quietly creating two more, compounding systemic fragility. Insurance assessors and defense accountants attempted to quantify the cascading losses, but spreadsheets failed to capture the strategic cost of time. Every stalled train represented not only destroyed hardware, but deferred offensives, missed artillery windows, and shifting battlefield momentum. In modern industrial warfare, logistics is tempo, and tempo once lost cannot be easily reclaimed. Rumors spread among railway workers stationed along remote sectors of track, many of whom had never before considered the cabinets beside them as potential targets. Some began conducting informal patrols during night shifts, scanning the tree lines with flashlights, listening for unfamiliar sounds in the forest. Yet the sheer geographic scale dwarfed any grassroots vigilance. Vigilance without density offered only illusionary security. Far from the frozen wreckage, military planners were forced to confront a sobering equation. Protecting every kilometer of rail would require resources rivaling those deployed at the front itself. The conflict had expanded into infrastructure, mathematics, and probability. Steel, electricity, and momentum had become weapons, and the battlefield now stretched invisibly across the vast Siberian night. At 1647 local time, a Russian Sukhoi Su-34 fullback roared off the runway at Saki Air Base in Crimea, its afterburners kicking up a haze of heat that distorted the horizon. The pilot and his weapons systems officer settled into the titanium armored cockpit, convinced this was just another routine milk run in a war they thought they were winning. Their mission profile was standard: a 40-minute sortie to deliver a pair of heavy glide bombs on coordinates provided by intelligence officers who likely had never stepped foot on a battlefield. The crew believed they were the hunters, apex predators in a $36 million machine designed to rain high-explosive death from the stratosphere. But what neither man knew was that they were already dead. They were simply ghosts flying a coffin that hadn't hit the ground yet. From the precise moment their landing gear retracted into the fuselage, a set of cold, unblinking eyes 18 kilometers inside Ukrainian territory had locked onto them, hidden deep within a dense tree line or covered by multispectral camouflage netting that scrambles both visual and thermal sensors. A Ukrainian Patriot battery commander was watching their every move. He wasn't relying on active radar that would scream his position to the enemy. He was tracking them using a network of passive sensors that listened to the electromagnetic whispers of the Russian jet. The pilot thought he was flying a stealthy mission, running silent with no radar emissions. In reality, the friction of air rushing over his airframe at 870 kilometers per hour turned his jet into a blazing torch on the thermal spectrum, a flashlight in a dark room that he couldn't switch off. The Sukhoi Su-34 climbed through 15,000 feet, banking onto a heading of 330 degrees. The pilot kept his eyes on the threat warning receiver, a circular display designed to alert him if a hostile radar locked onto his aircraft. It remained comforting and blank, showing nothing but the background static of the electromagnetic spectrum. To him, the sky was empty. His electronic warfare suite, the vaunted Kabini system mounted on the wingtips, showed green across the board. These pods are the pride of the Russian aerospace forces, advertised as being able to jam any Western missile system and create ghost targets that can fool even the most advanced radars. The weapons systems officer in the right seat began configuring the release parameters for their payload. They were carrying the devastating UMPK glide bombs, dumb iron bombs retrofitted with pop-out wings and satellite guidance kits. At 18,000 feet, they were 11 minutes away from the launch basket, a geometrically defined slice of airspace where physics dictates the bombs can glide to their target. The coordinates corresponded to a grid square in central Kherson. Maybe it was a command bunker, or maybe it was just another apartment block filled with civilians. The officer didn't care. His job was simply to align the math. But while they monitored their instruments, the laws of physics were plotting a different trajectory for their evening. The Ukrainian battery commander had been waiting for this specific geometry for weeks. This wasn't a target of opportunity. It was a mathematical trap set with the patience of a spider. The atmosphere inside the Ukrainian engagement control station was thick with the hum of cooling fans and the palpable tension of men who know they are hunting a dragon. The battery commander stared at his screens, analyzing the passive tracking data that was being fed to him via fiber optic cables to avoid radio frequency detection. The Russian bomber was flying fat, happy, and predictable, cruising at 24,000 feet and throttled back to conserve fuel. It was the perfect target, a gift wrapped in aluminum and titanium. However, the commander knew that in the world of high-end air defense, gifts usually explode in your face. The Su-34 is not a helpless target drone. It is a highly maneuverable frontline bomber, flown by experienced crews who know that ejecting over enemy territory is a sentence they don't want to serve. The moment the Ukrainian radar went active to guide a missile, the Russian jet would transform from a passive target into a desperate cornered animal fighting for survival. And worse, turning on the main radar, the massive AN/MPQ-65 phased array is the electronic equivalent of lighting a flare in the middle of a dark forest while surrounded by wolves. It reveals your exact location to every electronic intelligence sensor within a 300-kilometer radius. The commander had to make a choice that balanced the destruction of a high-value enemy asset against the lives of his crew and the survival of a billion-dollar weapon system. The passive tracking system was good, but it wasn't good enough for a firing solution. It estimated the bomber's position based on thermal contrast and triangulation, creating a margin of error that was roughly 12 kilometers wide at that range. Trying to guide a kinetic interceptor into a 12-kilometer question mark is like trying to hit a bullet with another bullet while blindfolded. To kill the bomber, the commander needed to collapse that uncertainty cone down to a few meters. He needed hard range, speed, and elevation data, and the only way to get that was to unleash the power of the C-band radar. This system pumps out enough microwave energy to cook a turkey from a football field away, but that energy acts as a beacon. The commander ordered a single surgical emission, 3 seconds. That was the limit. The radar panels phased up, blasted a focused beam of energy into the sky, and shut down before the echoes even fully decayed. On the screen, the blurry blob of the Russian jet sharpened instantly. The uncertainty cone collapsed from 12 kilometers to under 2. They had a fix, but 3 seconds wasn't enough to calculate the range rate, the precise speed at which the target was closing. They still didn't have a firing solution, and now the clock was ticking on their own survival. That 3-second burst of radar energy did not go unnoticed. 800 meters above the battery, circling silently in the gray overcast, was a Russian Orlan-10 reconnaissance drone. It is a crude device, powered by a lawnmower engine and held together with hardware store components. But it carries a signals intelligence payload tuned to detect exactly one thing: the specific frequency fingerprint of a Patriot radar. The moment the battery transmitted, the Orlan's sensors spiked. It didn't get a precise coordinate lock from such a short burst, but it narrowed the search area from a massive swathe of forest to a few hundred square meters. The drone operator, sitting safely in a truck kilometers away, relayed the data to a Russian fire coordination center. The hunt was on. Within 60 seconds, the first FPV drone signal appeared on the Ukrainian spectrum analyzers, vectoring toward the tree line at 110 kilometers per hour. These weren't standard surveillance drones. These were flying munitions, cheap quadcopters strapped with rocket-propelled grenade warheads, designed to weave through trees and slam into fragile radar faces. The hunter had just become the hunted, and the game of electronic cat and mouse was about to turn violent. A Ukrainian Bukovel electronic warfare truck, parked 400 meters east of the launcher, roared to life. Its operators detected the control link of the incoming kamikaze drone and activated a directional jamming cone. They flooded the specific frequency band with white noise, drowning out the pilot's commands. The FPV drone, suddenly severed from its human master, wobbled in the air before pitching forward and crashing harmlessly into a plowed field. But electronic warfare is a double-edged sword. Jamming a signal is loud. It requires broadcasting high-power noise, which acts like a spotlight pointing directly at the jammer. Russian electronic warfare analysts now had a second data point. They knew something in that tree line was valuable enough to be protected by a high-end jammer. That is the kind of intelligence conclusion that gets artillery grid coordinates plotted. 40 seconds later, a second FPV drone appeared. The Bukovel jammed it. Then a third appeared, but this one was operating on 2.4 gigahertz instead of the usual 5.8. The Russians were frequency hopping, probing the defenses, looking for a gap in the electronic armor. The Ukrainian operator was sweating, his fingers flying across the keyboard as he cycled between 3 different threat axes. Every jam was another broadcast, another breadcrumb for the Russian artillery that was undoubtedly spinning its gears to aim. The situation in the command trailer was deteriorating rapidly. The battery commander checked the passive track again. The Su-34 was now at 20,000 feet, just 8 minutes from its bomb release point. He still didn't have a lock. He ordered a second radar burst, 4 seconds this time. The phased array lit up the sky again. The return was crystal clear. Bomber at 22,000 feet, range 81 kilometers, closing speed 14.5 kilometers per minute. The track quality jumped to high confidence, but the engagement control station still flagged the solution as degraded. They needed one more update to guarantee a hit, but this second emission was the mistake that sealed the battery's exposure. The Orlan drone overhead caught the pulse repetition interval, the heartbeat of the radar. Every radar system has a unique signature, like a digital fingerprint. The Orlan matched it against its threat library instantly. It wasn't just a search radar. It was confirmed as a Patriot, the single highest priority target for the Russian military. Destroying a Patriot isn't just a tactical win. It's a propaganda victory worth billions. Suddenly, the FPV activity spiked. 5, then 6 drones appeared on the scope, probing from different angles, swarming like angry hornets. The Bukovel system was overheating, its internal cooling fans screaming as it tried to maintain an omnidirectional jamming bubble around the precious radar. While the electronic battle raged, a Ukrainian drone team operating from a ruined basement 600 meters behind the battery decided to go on the offensive. They couldn't stop the swarm, but they could kill the queen. Using the direction of the Russian control signals, they triangulated the position of the enemy drone operators. They found them hiding behind a concrete wall in a dilapidated farm complex. The Ukrainian pilot launched a kinetic strike drone, diving it straight into the source of the signals. The Russian transmission stopped abruptly, but in modern warfare, there is always backup. Another Russian cell took over almost immediately, and the probes accelerated. Then, one of the Russian FPVs slipped through the jamming net. The Bukovel operator was overwhelmed, handling 2 signals at once, and a small black shape weaved through the canopy at knee height, heading straight for the nearest launcher tube. A Ukrainian Overwatch drone spotted it just in time and rammed it in midair. Both machines detonated in a fireball in the underbrush, the shockwave rattling the teeth of the crew standing next to the launcher. And then, the ground shook. The distinct, terrifying rumble of a BM-21 Grad rocket barrage tore through the air. 40 rockets, each carrying high explosives, arced toward the general area of the radar emissions. The Russians didn't have a pinpoint fix, so they were deleting the entire grid square. The rockets impacted in a ragged, chaotic pattern about 1,000 meters north of the battery. The 2 short radar bursts had created a spread in the Russian targeting data, rather than a precise point. The explosions were close enough to shake the vehicles on their suspension, but far enough to spare them from shrapnel. A Ukrainian counter-battery radar, located kilometers away, instantly tracked the incoming trajectories, calculated the point of origin, and sent the coordinates to an M777 howitzer battery. Within 60 seconds, 6 Excalibur GPS-guided rounds were screaming downrange with 2-meter accuracy. The Russian Grad launcher was silenced before it could reload, but the clock was still the enemy. The battery commander looked at his display. The Su-34 was at 24,000 feet, entering the edge of the engagement window. One more radar emission would give him a firing solution, but this time, he couldn't just flash the radar and go dark. PAC-2 GEM-T interceptor missiles require continuous radar illumination to steer. They are semi-active seekers. They need the ground radar to paint the target with a continuous beam of energy all the way to impact. Think of it like a flashlight guiding a moth in the dark. If you turn off the flashlight, the moth goes blind. To kill the bomber, the commander would have to keep his radar on, screaming his position to the entire world for the entire duration of the missile's flight. It was a suicide pact with physics. If he turned the radar on for a continuous lock, every Russian sensor, every remaining drone, and every artillery piece in the sector would have a fixed, unmoving beacon to aim at. But the bomber was committed. At 1719, the Su-34 crossed the invisible line of no return. It was deep enough in the zone that any evasive turn would wreck its bombing run geometry. It was 90 seconds away from releasing its payload on the city. The commander didn't hesitate. At 1721, he ordered the radar to full power. This time, there was no 3-second limit. The beam blasted out, acquiring the bomber at 73 kilometers and locking it in less than 4 seconds. The fire control computer screamed, "Shoot." The first PAC-2 missile, a 900-kilogram telephone pole of high explosives and rocket fuel, roared off the rail, accelerating to Mach 5 in a heartbeat. The smoke trail pointed a giant white arrow right back to the launcher, and the continuous radar emission announced to the enemy that the gloves were off. The trap was sprung, but the hunter was now standing naked in the middle of the battlefield. In the Sukhoi's cockpit, the radar warning receiver didn't just beep. It lit up like a disco ball in hell. The pilot didn't need to consult the threat library to know what that continuous tone meant. A radar-guided missile was in the air, closing at hypersonic speeds. He immediately threw the 39-ton bomber into a violent defensive brake, rolling nearly inverted and pulling into a descending spiral that pinned both crew members into their ejection seats at 6 times the force of gravity. Simultaneously, the weapons systems officer frantically activated the Kaibini electronic countermeasure pods mounted on the wingtips. This system is designed to analyze the incoming radar frequency and transmit back a corrupted copy, injecting false range data and ghost targets to confuse the tracking solution. But the Patriot system isn't easily fooled. As the jet dispensed thousands of metallic chaff strips to create a radar reflective cloud 300 meters wide, the ground radar began frequency hopping, shifting its waveform hundreds of times a second to filter out the noise and keep its lock on the real metal skin of the aircraft. On the ground, the battery was tearing itself apart in a controlled panic. The moment the missile cleared the rail, the commander ordered an immediate displacement. Soldiers sprinted to the launcher stations, ripping out heavy data cables, while a tow vehicle backed up to an empty launcher. The Bukovel system shifted to omnidirectional jamming, a less focused but wider net, as the radar had to stay active. If they cut the beam now, the missile would lose its steering commands, turning a $3 million interceptor into a very expensive, unguided bottle rocket. So, the radar kept screaming its position to the enemy while everyone around it prepared to run. 30 seconds to impact. The bomber was pulling hard through its turn, bleeding altitude and energy. The Kaibini system cycled through jamming frequencies, but the Patriot was adapting in real time. The missile detonated roughly 60 meters from the airframe, its proximity fuse triggering a wall of preformed tungsten fragments. At that distance, the spread was too thin to kill, but it was enough to hurt. The bomber shuddered violently as warning lights cascaded across the dashboard. They were still flying, but the game had just changed from a bombing run to a survival horror story. The pilot faced a choice that had to be made in milliseconds: abort and run for Crimea with a damaged bird, or press toward the release basket and drop those bombs on Kherson as briefed. He chose the latter, shoving the throttles forward to claw back lost airspeed. On the ground, the battery commander watched the track data with cold calculation. He authorized a second shot. The radar had now been active for over 40 seconds. Russian fire coordination was certainly processing this continuous emission for another Grad rocket salvo. Every additional missile meant 15 more seconds of required radar time, 15 more seconds of broadcasting his exact coordinates to every artillery piece in the sector. But if he didn't fire, 3,000 kilograms of high explosives would glide 70 kilometers into a residential neighborhood. He fired. The second interceptor roared into the sky, chasing a bomber that was now at 18,000 feet with a quarter of its countermeasures already spent. The Patriot was getting smarter with every second of data, learning exactly how the Russian pilot broke and how the jammer cycled. The second missile didn't miss. It detonated close enough to pepper the fuselage with tungsten, sending the right engine temperature gauge climbing into the red. One missile presents a geometry problem for a pilot. 3 missiles launched seconds apart create a mathematical impossibility. They arrive from 3 different slices of airspace, each closing from a different angle, creating an inescapable kill box. Turn to defeat the first, and you fly directly into the path of the second. Dive to avoid the second, and the third has a clean shot against a 14-meter wingspan that is now moving 200 kilometers per hour slower than when the engagement started. The bomber pilot tried another brake turn, hauling the stick over as the last of his chaff cartridges fired from nearly empty dispensers. The moment the third missile cleared the rail, the radar operator on the ground switched the system to passive. He was done transmitting. The missiles in the air had enough reflected energy to ride home on, and the battery had overstayed its welcome by exactly 12 seconds. 73 kilometers away and 14,000 feet up, the Sukhoi Su-34 ran out of answers. Airspeed had dropped below 680 kilometers per hour. Countermeasures were dry. The first of the 3 missiles detonated within 15 meters of the left wing. The blast wave shredded the control surfaces, severed the remaining hydraulic lines, and punched through the engine housing like it was made of paper. The second missile detonated below the fuselage moments later, snapping the airframe's spine. Flight control vanished instantly. The bomber rolled uncontrollably as systems failed faster than the human brain could process. The third missile never even needed to arrive. The $36 million aircraft came apart over the Black Sea, turning into a cloud of burning debris and unspent fuel. Neither FAB-1500 bomb was released. The strike on the city never happened. The only thing that fell from the sky was a rain of aluminum and regret. At 0230 hours on January 14, 2026, the radar screens at the Kapustin Yar test site in the Astrakhan region flickered with a ghost that should not have been there. This facility is not just a military base. It is the holy grail of Russian rocketry, the exact coordinates where the Soviet Union launched its first ballistic missiles and where the new Oreshnik hypersonic systems were currently being assembled in secret clean rooms. The Russian operators inside the command bunker were relaxed, staring at displays that showed the empty airspace over the desolate steppe, protected by what Moscow claimed was the most impenetrable air defense bubble on the planet. They had every reason to feel safe because Kapustin Yar sits nearly 600 kilometers from the Ukrainian border, deep inside Russian territory, shielded by layers of S-400 batteries and the new S-500 Prometheus system. But what they did not know was that 12 minutes ago, a heavy transport truck parked on a generic highway in eastern Ukraine had just lowered its hydraulic stabilizers and raised a massive launch canister toward the sky. Inside that tube was something Russian intelligence had never seen before: the Flamingo. This was not a repurposed Soviet drone or a foreign-supplied cruise missile with restricted range. It was a domestic monster, a completely Ukrainian-engineered heavy cruise missile carrying a warhead weighing 1,000 kilograms, designed specifically to crack open concrete bunkers that standard munitions would just scratch. The launch itself was deceptive because the Flamingo does not scream off the rail like a tactical missile. It starts with a cold launch, ejected by compressed gas before its main turbine ignites 30 meters in the air. This eliminates the massive infrared bloom that usually alerts American and Russian missile warning satellites instantly. By the time the solid fuel booster kicked in, the truck was already retracting its stabilizers to disappear into civilian traffic. The missile accelerated to 0.8 Mach, staying under 50 meters of altitude, hugging the terrain like a cruise missile is supposed to, but with one terrifying difference. Most cruise missiles like the Tomahawk or Storm Shadow are cigar-shaped and relatively fragile, but the Flamingo is built like a flying tank, utilizing a box-wing design that provides immense lift for its massive payload. It was carrying 1 ton of high explosives, which is roughly double the payload of a standard Tomahawk. The physics here are simple but brutal. Force equals mass times acceleration. When you slam 1,000 kilograms of high-grade explosive encased in a hardened penetrator cap into a building at 900 kilometers per hour, you do not just damage the structure, you liquefy the foundation. As the missile crossed the front lines, it dropped even lower. to just 15 meters above the frozen ground, navigating using a terrain reference system that does not rely on GPS, effectively making it invisible to the jamming stations the Russians had set up to blind Western weapons. 300 kilometers into the flight, the Russian air defense network finally woke up. A Nebo-M radar station positioned near Volgograd picked up a faint, intermittent signal. The radar operator was confused because the cross-section was fluctuating wildly. 1 second it looked like a small fighter jet, and the next, it looked like a massive transport plane. This was intentional. The Flamingo is coated in radar-absorbent material, but its sheer size makes true stealth impossible. So Ukrainian engineers used active electronic countermeasures built into the missile's skin. These emitters broadcast false returns, ghost signals that made the radar computer think there were 3 targets, then 0, then 5. The Russian operator followed standard protocol and alerted the nearest Pantsir S-1 battery to intercept what he thought was a group of slow-moving drones. The Pantsir crew swiveled their turret, their optical cameras searching the dark sky for the telltale heat signature of drone engines. They were looking for something small and slow, buzzing along at 150 kilometers per hour. Instead, the Flamingo roared past their position at 900 kilometers per hour, so low that the shockwave shattered the windows of the control vehicle before they could even lock a target. By the time the Pantsir commander screamed for a launch, the missile was already 5 kilometers downrange, disappearing behind a ridgeline. The failure at Volgograd triggered a panic in the command chain because the trajectory was now clear. The object was heading straight for the strategic heart of the Astrakhan region. The S-400 battalion guarding Kapustin Yar was ordered to weapons-free status. This system is legendary for a reason. Its 92N6 gravestone radar can track 100 targets simultaneously and guide missiles to engage them at ranges of up to 400 kilometers. But here is the problem with physics that no amount of propaganda can solve: the radar horizon. Radar beams travel in straight lines, but the Earth is curved. Against a target flying at 15 meters altitude, even the most powerful radar in the world cannot see it until it is approximately 30 kilometers away. That gives the defense crew about 120 seconds to detect, identify, lock, and fire. The Russian commander knew this math, so he ordered an A-50 mainstay AWACS aircraft patrolling over the Caspian Sea to turn north and look down. The A-50's radar, looking from 30,000 feet, has no horizon limitations. It spotted the Flamingo immediately, a hot, fast-moving thermal scar against the cold winter ground. The data was data-linked instantly to the S-400 battery. Now they had a firing solution without needing their own radar to see the target. At 02:45 hours, the S-400 battery launched 2 40N6 missiles. These are the long arms of the Russian defense, massive interceptors capable of reaching hypersonic speeds of Mach 14. They climbed into the stratosphere, burning white-hot, intending to dive down on the Flamingo from above. This is the standard interception profile: gain energy by climbing, then convert that altitude into speed for the kill. The Ukrainian missile was cruising blindly, seemingly unaware that 2 telephone pole-sized killers were arching down toward it at 4 kilometers per second. But the Flamingo was not just a dumb bomb with wings. As the S-400 missiles entered their terminal dive phase, activating their own active radar seekers to find the target, the Flamingo's radar warning receiver screamed that it was being painted. The onboard computer, running an algorithm trained on thousands of simulations, executed a maneuver that should have been impossible for a missile that heavy. It fired emergency separation bolts, jettisoning aerodynamic fairings on its wings to abruptly change its lift profile, and pulled a 6G turn while simultaneously dropping to 5 meters altitude, literally skimming the wavetops of a frozen reservoir. The S-400 missiles traveling at Mach 14 simply could not turn that tight. The laws of inertia are unforgiving. At that speed, your turning radius is measured in kilometers. The interceptors realized too late that the target had jagged left. They tried to correct, their control fins straining, but they overshot, slamming into the ice 2 kilometers away from the Flamingo. The Russian commanders at Kapustin Yar watched the telemetry feeds go flat and realized with horror that the kinetic kill option had failed. They had one card left to play: electronic warfare. The base was protected by the Pole 21 system, a massive area denial jammer designed to flood the electromagnetic spectrum with so much noise that satellite navigation becomes impossible. They cranked the power to maximum, frying civilian cellular networks for 50 kilometers in every direction. The idea was to confuse the missile's GPS receivers, causing it to drift off course and crash harmlessly into the empty steppe, and it worked partially. The Flamingo's satellite link was severed instantly. The blue line on the Russian tracking map showed the missile's projected path beginning to widen, indicating a loss of precision. The officers in the bunker exhaled, believing the threat was neutralized. But they had underestimated the redundancy of the Ukrainian guidance package. When the GPS signal died, the Flamingo did not panic. It simply switched to its tertiary guidance mode, Digital Scene Matching Area Correlator. A camera in the nose came online, snapping hundreds of infrared photos of the ground per second and comparing them to a preloaded 3D map of the terrain stored in its hard drive. It did not need satellites. It was reading the ground like a map. It recognized the bend in the river, the specific shape of the power lines, and the railway junction. It corrected its course, banking hard to the right, locking its nose directly onto the coordinates of the Oreshnik Assembly Hall. Now the missile was inside the 10-kilometer death zone, the final layer of defense where point defense systems like the Tor M2 and the Pantsir operate. These are the goalies, designed to catch whatever leaks through the long-range net. A Tor M2 vehicle parked on the perimeter of the assembly complex picked up the Flamingo. The Tor is a terrifyingly efficient machine, carrying 16 vertical launch missiles that can be fired in seconds. Its radar locked on, and the computer calculated a 100% kill probability. The Flamingo was big, it was low, but it was straight and level for the final approach. The Tor commander pressed the button, and 2 missiles leaped from the vertical tubes, turning sharply to intercept. This time, there would be no fancy maneuvers. The range was too short, and the physics were too tight. The first Tor missile detonated 10 meters in front of the Flamingo, spraying a cloud of tungsten shrapnel directly into its flight path. The heavy Ukrainian missile flew right through the cloud. The shrapnel shredded the outer composite skin, punched holes in the intake, and severed the hydraulic line to the left elevon. But the Flamingo was built with the ruggedness of a tank. Its structural spar was solid titanium, designed to survive exactly this kind of punishment. Smoke trailed from its engine, and the missile listed 5 degrees to the left, but its momentum was unstoppable. The 1,000-kilogram warhead was armored, immune to the light shrapnel of an anti-air missile. The Russian operators watched in disbelief as the burning missile emerged from the smoke of the explosion, still flying, still closing. It was now 3 seconds from impact. The Tor system tried to fire again, but the reload cycle took 4 seconds. The Flamingo was moving at 250 meters per second. The math was over. The target was the main assembly hall, a massive structure with reinforced concrete walls where the delicate components of the Oreshnik ballistic missiles were being calibrated. The Flamingo did not just hit the wall, it activated a delayed fuse. The penetrator cap punched through the 2-meter-thick concrete like a needle through fabric. The missile buried itself deep inside the central bay of the factory before the fuse timer hit 0. Inside, the hall was filled with volatile solid rocket fuel and precision electronics. When 1,000 kilograms of high explosives detonated, the effect was not an explosion. It was an erasure. The overpressure wave instantly turned the building's interior into plasma. The roof, weighing hundreds of tons, was lifted 50 meters into the air on a column of fire. The shockwave propagated outward, shattering the windows of the command bunker 2 kilometers away and knocking the radar dishes of the S-400 battery off their alignments. Gemini had gesagt. The immediate aftermath of the Flamingo's impact at Kapustin Yar was not just destruction. It was a strategic blind spot opening up in real time. The primary assembly hall for the Oreshnik missile program was now a crater 20 meters deep, burning with the intensity of a chemical fire that water could not extinguish. Inside the bunker, the Russian commanders were trying to make sense of the sensors that were still online. Their screens showed static where the assembly hall used to be, and the seismic sensors registered a tremor equivalent to a magnitude 3.5 earthquake. But the real horror was not the fire. It was the silence on the radar. The blast had severed the fiber optic cables connecting the northern sector's early warning radar to the central command. For 3 minutes, the entire northern approach to the base was dark. And in modern warfare, 3 minutes is an eternity. While the Russians were scrambling to reroute data through backup links, a second truck, parked in a forest clearing in the Sumy region of Ukraine, had already finished its launch sequence. This was not firing another Flamingo. It was firing something much smaller, much cheaper, and far more dangerous to an air defense system that is already panicking: the Palyanitsia rocket drone swarm. 12 of these small, jet-powered drones screamed across the border at 600 kilometers per hour. They were not carrying heavy warheads. In fact, half of them were carrying nothing but radar reflectors and electronic warfare emitters. Their job was not to kill, it was to scream. They were programmed to fly in a formation that mimicked the radar signature of a squadron of F-16 fighter jets. As the backup radar at Kapustin Yar finally flickered back to life, the operators saw what looked like a full-scale NATO air raid inbound from the west. The psychological impact was immediate. The Russian commander, staring at 12 high-speed contacts closing at Mach 0.6, made the only decision he could. He ordered the S-500 Prometheus battery to engage. This system is the crown jewel of Russian defense and designed to shoot down satellites in low Earth orbit and hypersonic glide vehicles at Mach 20. Using it against plastic drones is like using a diamond drill to hang a picture frame. It works, but the cost is ruinous. Each 77 N6 interceptor missile costs approximately $4 million. The Palyanitsia drone costs about $50,000. But the commander did not care about the budget. He cared about survival. The S-500 battery roared to life, its massive launch tubes elevating with a hydraulic whine that could be heard for kilometers. In rapid succession, 6 interceptors launched, trailing pillars of fire that turned the night sky into day. These missiles are marvels of engineering, accelerating to Mach 10 in seconds, designed to maneuver in the thin air of the upper atmosphere. But the Ukrainian drones were hugging the deck at 30 meters. The S-500's radar, optimized for space tracking, struggled to filter out the ground clutter. Radar returns from trees, hills, and buildings. The interceptors dove from the stratosphere, their seekers searching for the cold plastic bodies of the drones against the relatively warm Earth. 3 of the missiles lost lock and slammed into the ground, creating craters that would be mistaken for bomb impacts later. The other 3 found their marks. 3 Palyanitsias vaporized in midair, their debris raining down on the steppe. The Russian operators cheered, believing they had stopped the main attack. They had just spent $12 million to destroy $150,000 of decoys. And while they were high-fiving, the real threat, a second Flamingo missile that had been flying silently behind the drone swarm, pitched up and accelerated. This second Flamingo was different. It was the B variant, equipped with a specialized warhead designed for deep penetration of hardened command bunkers. It had used the chaos of the drone swarm to mask its approach, flying in the shadow of the S-500's engagement radar. When the interceptors detonated, the electromagnetic interference blinded the sensors for exactly 4 seconds. That was all the Flamingo needed to close the final 5 kilometers. But the Russians had one last layer of defense, the Pantsir SM. This updated version of the short-range system has new high-velocity missiles specifically designed to catch low-flying cruise missiles. The Pantsir on the southern perimeter locked onto the Flamingo at 4 kilometers. The automated turret spun, the twin 30mm cannons spooled up, and 2 missiles launched instantly. The physics of this engagement were brutal. The Flamingo was heavy and fast. The Pantsir missiles were light and agile. The first interceptor clipped the Flamingo's right wing, tearing off the control surface. Any normal aircraft would have rolled over and crashed, but the Flamingo's flight computer, sensing the roll, fired a bank of explosive bolts on the left wing, deliberately jettisoning half of its own lifting surface to balance the drag. It was a suicidal maneuver, stripping the missile of its ability to turn or climb, turning it into a lawn dart with a rocket engine. It was now falling on a ballistic trajectory, aimed not at the coordinates in its memory, but simply at the ground where its momentum carried it. The Russian operators watched the track degrade, assuming a kill, but momentum is a stubborn thing. The missile, now barely airworthy, was still traveling at 800 kilometers per hour. It slammed into the ground 100 meters short of the main command bunker. The impact was not a precise strike on the ventilation shaft as planned, but it did not matter. 1,000 kilograms of high explosives detonated in the soft soil of the courtyard. The shockwave propagated through the ground, hitting the concrete walls of the buried bunker like a hammer hitting a bell. Inside, the lights died, the oxygen scrubbers failed, and the delicate server racks running the S-500's fire control software toppled over. The base was now blind, deaf, and burning. The Oreshnik production line was gone. The S-500 system was offline due to a server crash caused by the shockwave. And the cost to Ukraine? 2 trucks, 2 missiles, and 12 cheap drones. The cost to Russia was incalculable. It was not just the billions of rubles in destroyed infrastructure, it was the loss of the sanctuary concept. For decades, Russian military doctrine assumed that bases like Kapustin Yar were untouchable. At 0314 hours local time on July 30th, 2025, A senior radar operator at the Voronezh-Malshevo Air Base was fighting the urge to close his eyes for just 5 seconds. He had been staring at the glowing green sweep of his Nebo-M radar screen for 6 straight hours, unaware that 200 kilometers to the south, a swarm of 38 Ukrainian-made long-range drones had already crossed the border and were currently flying nap of the Earth at an altitude of just 40 meters. In exactly 112 seconds, his routine night shift would dissolve into absolute chaos, marking the beginning of the single largest coordinated aerial offensive of the entire war. This was not a localized skirmish or a probing attack. Ukrainian mission planners had synchronized a strike package targeting 13 separate Russian regions simultaneously, stretching from the naval facilities in Sevastopol to the strategic oil refineries deep within the Russian interior. The operator's screen showed nothing but static and ground clutter, exactly as the Ukrainian engineers intended. The attacking aircraft were not the standard commercial quadcopters modified for trench warfare, but the latest iteration of the Lyuty airborne drone, a low-cost aluminum and fiberglass monoplane that looks like a high school science project, but functions like a strategic cruise missile. Powered by a simple 50-horsepower internal combustion engine that sounds like a lawnmower, the drone carries a 75-kilogram warhead over a range of 1,000 kilometers, all for a price tag lower than a mid-range family sedan. While the Russian radar operators scanned the skies for high-altitude threats, the Ukrainian drone swarm was exploiting the physics of radar horizons. By flying below the tree line and following the contours of riverbeds, the drones remained invisible to long-range search radars that are designed to track fighter jets at 30,000 feet. But this low-altitude approach came with its own set of lethal risks. At 03:16 hours, the lead drone in the Voronezh sector, designated Alpha 1, encountered a sudden localized jamming field emitted by a Pol-21 electronic warfare system. The system, mounted on a generic cell tower, began blasting noise across the GPS L1 and L2 bands, attempting to sever the drone's connection to its satellite navigation constellation. For 99% of commercial drones, this would result in an immediate crash or a drift into nowhere. But the Lyuty's guidance computer had been upgraded with terrain reference navigation software. As the GPS signal dissolved into electronic static, the drone's downward-facing optical sensor began comparing the ground features below, roads, rivers, and tree lines, against a preloaded digital map stored in its internal memory. It was flying by sight in the middle of the night, correcting its course based on the geometry of the landscape rather than signals from space. The Russian electronic warfare officer watching his jamming efficiency monitor saw the signal disruption and assumed the threat was neutralized, completely unaware that the drone had simply switched its brain to a different mode and was continuing its terminal approach at 150 kilometers per hour. Simultaneously, 800 kilometers to the south, the situation over the Crimean Peninsula was deteriorating rapidly for the Russian Black Sea Fleet. At 03:22 hours, air raid sirens began wailing across Sevastopol as a separate wave of Ukrainian drones approached from the sea. Unlike the silence of the overland approach, the maritime strike package was designed to be loud and visible, a deliberate tactic to overwhelm the localized air defense grid. The Russian Panzer S-1 defense systems stationed around the harbor swung their turrets toward the incoming contacts, their phased array radars lighting up the night with tracking beams. The Panzer is a formidable system, theoretically capable of tracking 20 targets and engaging 4 simultaneously with hypervelocity missiles. However, the Ukrainians were sending 12 drones at a single battery. It was a simple mathematical saturation attack. The first 4 drones were merely decoys, inexpensive foam-constructed wings fitted with Lundberg lenses, radar reflectors that made them appear as large as fighter jets on the Russian scopes. As the Panzer batteries unleashed their missiles at these phantom targets, depleting their ready-to-fire ammunition, the actual strike drones, hugging the waves at 5 meters above sea level, slipped through the engagement envelope. The lead drone, carrying a specialized shaped charge warhead, was not aiming for a ship, but for the fuel storage facility that kept the fleet moving. The Russian operators were effectively playing a video game where the enemies spawn faster than the reload animation allows, and the game over screen involves a massive fireball. Back in the Ryazan region, the target was purely economic. The Ryazan oil refinery, one of the largest in Russia, processes 17 million tons of crude oil annually, turning black sludge into the jet fuel that powers the Russian Air Force. At 03:30 hours, the facility was fully illuminated, a city of steel pipes and distillation columns glowing under industrial floodlights. To a drone's optical guidance system, it was the easiest target in the world. The specific aim point was not the storage tanks, which look spectacular when they explode but are easily replaced. The target was the primary atmospheric distillation column, a complex piece of engineering that separates crude oil into usable fractions. It is a 60-meter tall steel tower that takes 2 years to manufacture and install. Destroying it doesn't just burn fuel, it shuts down the entire refinery for 18 months. The approaching drone, now 5 kilometers out, began its terminal dive maneuver. The onboard flight controller adjusted the throttle to maximum, pushing the small piston engine to its limit. On the ground, a private security guard armed with an anti-drone gun looked up at the buzzing sound. He raised his rifle, a futile gesture against a 75-kilogram projectile moving at 180 kilometers per hour. The physics of kinetic energy meant that even if he managed to hit the drone with small arms fire, the wreckage would still slam into the delicate infrastructure with the force of a car crash. The impact at Ryazan occurred at precisely 0332 hours. The warhead did not just detonate on the surface of the distillation column, it utilized a delayed fuse set for 3 milliseconds after contact. This allowed the kinetic energy of the drone to punch through the outer steel cladding and insulation before the explosive charge triggered. The result was an internal overpressure event that turned the distillation tower into a giant pipe bomb. The blast wave shredded the internal trays used for chemical separation and ruptured the pressurized feed lines carrying superheated crude oil. Instantly, the volatile hydrocarbons ignited, creating a vertical column of fire that reached 100 meters into the night sky. But the true damage was structural. The heat from the burning oil began to soften the steel supports of the adjacent towers. Within 45 seconds, the structural integrity of the main processing unit failed, causing the massive tower to buckle and collapse onto the control center below. Millions of dollars of specialized petrochemical equipment were reduced to twisted scrap metal in less than a minute. The secondary explosions were visible on satellite thermal imagery from orbit, registering a heat signature so intense that automated forest fire detection algorithms in Europe triggered false alarms. This was the reality of the new war of attrition. A $20,000 drone had just inflicted $500 million in damage and erased 4% of Russia's refining capacity in the blink of an eye. Meanwhile, the scale of the operation was becoming apparent to the Russian National Defense Control Center in Moscow. Reports were flooding in from 13 different regions: Belgorod, Bryansk, Kursk, Voronezh, Rostov, Krasnodar, and beyond. The map of European Russia was lighting up with red icons indicating strikes and interceptions. Russian air defense commanders were paralyzed by the sheer breadth of the attack. They had concentrated their best systems, the S-400 and S-300 batteries, around Moscow and the front lines, leaving vast gaps in the interior coverage. The Ukrainian planners had spent months analyzing these gaps, using data from partisan spotters and open-source satellite imagery to plot flight paths that threaded the needle between radar bubbles. In the Oriol region, a drone aimed at a logistics hub was intercepted by a Tor M2 missile system, but the debris rained down on the intended railway switchyard, severing the power lines and fusing the track switches. Even a failure was a partial success. The psychological impact was even more severe. By hitting 13 regions simultaneously, Ukraine demonstrated that there was no safe rear area. Every fuel depot, every ammunition dump, and every airfield within 1,000 kilometers of the border was now a valid target. The illusion of distance, which had protected the Russian interior for the first 3 years of the war, had been shattered by a fleet of flying lawnmowers built in a garage. The most technically complex part of the operation was taking place over the Sea of Azov, where a group of modified Magura 5C drones were coordinating with the aerial assault. While the aerial drones drew the attention of the radars upwards, these unmanned surface vessels were skimming across the water toward the Kerch Strait. At 0345 hours, a Russian K-27 Helix helicopter, flying patrol near the bridge, spotted the wake of the lead sea drone. The pilot immediately engaged, strafing the water with machine gun fire. But the sea drone was not a passive target. This new variant was equipped with a modified R-73 air-to-air missile adapted for surface launch. As the helicopter banked for a second run, the drone's optical sensors locked onto the heat of the helicopter's engine exhaust. In a twist of modern warfare irony, the hunter became the hunted. The missile leaped from the rails on the tiny boat, covering the 2 kilometers to the helicopter in 4 seconds. The pilot never saw it coming. The explosion tore the tail rotor off the helix, sending the $12 million aircraft spinning into the dark water. The loss of the patrol helicopter created a blind spot in the defensive perimeter, a gap that the remaining sea drones immediately exploited, accelerating toward the bridge supports at 40 knots. Back in the Voronezh region, the initial strike on the airbase had triggered a massive secondary response. Fire crews were rushing toward the burning fuel farm, their sirens wailing in the night. But this response was exactly what the second wave of drones was waiting for. Known as a double-tap strike, a tactic as ruthless as it is effective, the second group of drones had been loitering in a holding pattern 10 kilometers away, listening for the radio traffic of the emergency services. At 03:55 hours, as the firefighters began deploying their hoses to fight the chemical fire, the second wave began its terminal dive. The objective was to disable the specialized firefighting vehicles and panic the personnel, ensuring the initial fire could burn out of control. It is a grim calculus, trading human lives for strategic destruction. The lead drone targeted the specialized airport crash tender, a massive vehicle crucial for extinguishing jet fuel fires. The impact turned the vehicle onto its side, shattering the windshield and igniting its own diesel tanks. The message was clear. Not only can we hit you, but we can also prevent you from fixing the damage. As dawn approached, the smoke from 13 different regions began to rise, creating black streaks against the morning sky that would be visible for miles. The Russian Ministry of Defense would claim they intercepted 80% of the targets, but the physics of burning oil refineries and cratered runways told a very different story. At 0415 hours, while the fire crews in Ryazan were losing their battle against physics and chemistry, the Russian air defense grid in the Tula region was experiencing a different kind of nightmare. The operators of an S-400 Triumph battery, a system that costs roughly $500 million and is touted as the best in the world, were staring at screens that looked like a chaotic, abstract painting. The Ukrainian mission planners had not just sent explosive drones. They had deployed a squadron of specialized electronic warfare decoys. These were modified commercial fixed-wing platforms carrying nothing but a battery and a jammer broadcasting noise on the X-band frequencies used by the S-400's engagement radar. To the Russian system, these cheap decoys appeared as a wall of incoming threats, forcing the automated fire control computer to prioritize targets based on signal strength rather than actual threat level. The battery commander, sweating in his command vehicle, authorized the launch of 6 40N6 long-range missiles. Each missile costs approximately $1.2 million. In less than 30 seconds, the Russian Federation spent $7.2 million to intercept 6 drones made of plywood and styrofoam that cost a combined total of $12,000. This was the economic asymmetry of modern war distilled into a single engagement. One side is spending the GDP of a small town to shoot down a high school science project, and they are still losing the exchange rate by orders of magnitude. As the decoys absorbed the expensive interceptors, the real payload slipstreamed through the gap in the radar coverage. 2 heavy-lift Baba Yaga drones, converted from agricultural sprayers to bombers, were approaching the Uzlovaya power substation. This facility is a critical node in the regional energy grid, stepping down 330 kilovolts for industrial use. The drones did not need to hit the transformers directly with explosives to cause a catastrophe. Instead, they dropped spools of conductive carbon fiber filaments directly onto the high-voltage bus bars. As the conductive material drifted down, it created thousands of short circuits simultaneously across the phases. The resulting electrical arc flash was brighter than the sun, vaporizing the copper windings inside the 300-ton transformers and boiling the insulating oil instantly. The explosion blew the ceramic insulators into shrapnel that shredded the control lines, cascading the failure through the grid. Within 3 seconds, 40% of the industrial capacity in the Tula region went dark, halting production at 3 munitions factories that relied on that stable power supply. The damage to the transformers was not just physical. These massive units take 6 to 12 months to manufacture, and with sanctions blocking the import of specialized high-voltage components, the lights in Tula were not coming back on anytime soon. By 0500 hours, the sun was rising over the logistical hub of Rostov-on-Don, revealing the extent of the coordinated chaos. This region serves as the primary artery for supplying Russian forces in occupied Ukraine, and the Ukrainian planners had targeted the railway marshalling yards with surgical precision. A swarm of 4 smaller FPV drones, guided by fiber optic cables to remain immune to the desperate jamming now flooding the airwaves, had struck the switching mechanisms of the main north-south line. They didn't blow up the tracks, which are easily repaired. They fuse the intricate manganese steel frogs of the switches, the mechanical hearts of the railway that allow trains to change tracks. Replacing a custom-cast railway switch takes a specialized engineering team 2 days, but the real damage was the backlog. Within 4 hours, 12 supply trains carrying ammunition, fuel, and armored vehicles were backed up for 60 kilometers, sitting stationary and exposed. To a satellite passing overhead, the line of stalled trains looked like a buffet for long-range artillery. The paralysis of the logistical network was more damaging than destroying any single tank battalion because a tank without fuel is just a heavy metal box, and a soldier without ammunition is just a target. The ripple effect of these 4 small explosions would be felt on the front lines in Donetsk 3 days later, when the expected artillery shells simply failed to arrive. The psychological impact of hitting 13 regions simultaneously cannot be overstated. In the deep rear, specifically in the Astrakhan region near the Caspian Sea, the target was the delicate specialized equipment used for launching cruise missiles from naval vessels. The strikes here were small, almost negligible in terms of TNT tonnage, but devastating in their precision. A single drone struck the calibration alignment tower at the naval base, a sensitive optical instrument used to program the guidance systems of Caliber missiles before they are loaded onto ships. Without this calibration, the missiles are effectively blind. The explosion knocked the tower 3 degrees off its axis, a shift invisible to the naked eye but catastrophic for a guidance computer. It would take Russian engineers weeks to diagnose why their missiles were suddenly missing targets by kilometers. And by the time they realized the calibration tower was compromised, the fleet's effectiveness would have been degraded by 40%. This was the genius of the operation. It wasn't just about blowing things up. It was about introducing friction, error, and doubt into every level of the Russian war machine. As the morning briefings began in Moscow, the grim arithmetic of the night's work became clear. The Russian Ministry of Defense claimed to have shot down 82 drones, a number that sounded impressive until you looked at what the remaining 18 had achieved. The total cost of the Ukrainian strike package, including the drones, the fuel, the intelligence gathering, and the decoys, was estimated at roughly $3.5 million. The cost of the Russian air defense missiles fired in panic was $40 million. The physical damage to refineries, substations, and rail infrastructure exceeded $600 million. But the lost economic output, the delayed logistics, and the strategic paralysis were worth billions. The operation had achieved a return on investment of roughly 17,000%. It demonstrated that in the age of drone warfare, the defender has to be lucky every single time, while the attacker only has to be lucky once. And on the night of July 30th, 2025, the laws of probability and physics were firmly on the side of the engineers in Kyiv. At 02:15 hours on a moonless night, a silent flotilla ascended into the dense air over eastern Ukraine. This was not a traditional drone swarm, but a calculated blend of 19th century physics and 21st century artificial intelligence. High-altitude military weather balloons, stripped of their standard meteorological payloads, were released into the prevailing easterly wind currents. Their destination was the Metafrax chemicals plant in the Perm region, an industrial fortress located nearly 1,000 miles deep inside Russian territory. Each balloon carried a specialized payload, utilizing solar panels to power advanced sensor arrays and artificial intelligence-assisted navigation modules. This silent vanguard was engineered by the security service of Ukraine's Alpha unit, designed specifically to bypass the dense electromagnetic warfare networks that had increasingly complicated low-altitude drone strikes. They rose at 3 meters per second, slipping past early warning radars that were desperately scanning the horizon for low-flying aluminum airframes, completely ignoring the slow, radar-absorbent spheres drifting upward into the stratosphere. By 04:30 hours, the balloon Vanguard reached an altitude of 25,000 feet, catching the high-speed jet streams flowing toward the Ural Mountains. 300 miles away, Russian operators manning a pod-lit radar system stared at their screens, their algorithms optimized to detect the fast, low-altitude signatures of cruise missiles and kamikaze drones. The balloons, constructed from specialized synthetic polymers, presented a radar cross-section virtually indistinguishable from background atmospheric clutter. Moving at exactly the speed of the ambient wind, they generated zero thermal signature, rendering infrared tracking systems completely useless. Inside the command centers, Russian air defense personnel logged a quiet night. unaware that a fleet of silent carriers was actively mapping their blind spots. These balloons acted as a high-altitude Trojan horse, mapping the specific frequencies of Russian air defense batteries, quietly transmitting this data back to operators in Kyiv via encrypted burst transmissions. This integration of low-cost aerostats with sophisticated artificial intelligence represents a paradigm shift in deep strike operational doctrine. By utilizing wind currents, the Ukrainians essentially bypassed the severe fuel limitations that normally restrict the operational radius of rotary or fixed-wing drones. As the balloons drifted over the Perm region, nearing the 1,000-mile mark from the Ukrainian border, they approached their primary objective. The Metafrax Chemicals facility in Gubaka was not just a civilian factory, it was a critical node in the Russian military-industrial complex. The plant was responsible for producing massive quantities of methanol, hexamine, urea, urotropine, penterythritol, and formalin. These synthetic resins and chemical compounds are the foundational explosive precursors required for manufacturing solid rocket propellant and high-explosive artillery shells. Destroying this facility would not merely inconvenience the Russian war machine, it would directly sever the chemical supply chain required to maintain their artillery dominance on the front lines. The facility was considered untouchable due to its extreme geographic depth. At precisely 0512 hours local time, the artificial intelligence modules aboard the balloons calculated the optimal release coordinates based on real-time wind shear data and barometric pressure. Micro-explosive bolts severed the physical connections, dropping a payload of long-range loitering munitions directly over the Gubaka industrial zone. Because these drones were deployed from high altitude directly above the target, they bypassed the outer rings of point defense systems entirely. They initiated a steep, unpowered glide, their electric motors remaining silent to avoid acoustic detection by ground patrols. The target complex below sprawled across several square miles, a maze of highly pressurized pipes, distillation columns, and massive storage tanks holding volatile precursor chemicals. A single miscalculation in the terminal guidance phase would result in the munitions striking reinforced concrete instead of the vulnerable chemical containment vessels. The drones utilized electro-optical sensors to match the industrial layout against preloaded satellite imagery, making minor adjustments to their control surfaces 50 times per second as they plummeted. At 0515 hours, the lead drone identified the primary hexamine synthesis unit, the heart of the explosive precursor production line. A Russian Panzer air defense system stationed nearby finally detected the incoming threat as the drone descended below 1,000 feet. But the system required exactly 7 seconds to achieve a firing solution. The drone was only 4 seconds away from impact. At 0515 and 4 seconds, the warhead penetrated the thin steel roofing of the synthesis facility, detonating its 40-kilogram payload of high explosives directly beside a pressurized line containing superheated methanol. The initial blast wave shattered the surrounding containment vessels, instantly atomizing thousands of gallons of volatile chemicals into a highly combustible vapor cloud. 2 milliseconds later, the ambient heat from the primary explosion ignited this vapor, creating a massive thermobaric secondary blast that ripped the roof off the facility and sent a pillar of fire 300 feet into the pre-dawn sky. The shockwave cascaded through the plant, triggering safety valves that immediately vented more flammable material. By morning, the Metafrax Chemicals plant was paralyzed, its critical infrastructure reduced to a landscape of twisted, burning metal. The Russian Ministry of Defense immediately issued a standard press release, officially claiming that their air defense networks had successfully intercepted and destroyed every single incoming Ukrainian drone over the Perm region. However, thermal imaging satellites and local open-source intelligence confirmed a massive, uncontrollable fire raging at the exact coordinates of the chemical processing units. This deep strike demonstrated a total nullification of Russia's presumed geographic depth advantage. Historically, the Kremlin relied on vast territorial expanses to protect its military-industrial base from enemy action, assuming that factories located 1,000 miles inland were entirely safe from conventional attacks. The security service of Ukraine's Alpha unit had shattered this doctrine, proving that they could deliver precision strikes against irreplaceable chemical logistics nodes anywhere within the Russian Federation, forcing Moscow to urgently reconsider the safety of its deepest industrial assets. Simultaneously, while the fires in the Perm region were still burning, a second coordinated strike package was executing a totally different mission profile over the Black Sea. At 0630 hours, a swarm of low-flying naval and aerial drones converged on the Taman-Naftogaz oil terminal located in the Krasnodar region. This facility represents one of Russia's most critical maritime export hubs, funneling millions of barrels of crude oil and refined petroleum products to global markets. This attack marked the second time in less than 30 days that Ukrainian forces had penetrated the terminal's layered defensive perimeter. The strategy here shifted from degrading military production to inflicting severe financial hemorrhage. The drones skimmed just a few feet above the ocean's surface, utilizing the curvature of the earth and wave clutter to hide from coastal radar installations. Their target was not just the physical storage tanks, but the economic confidence of the entire Russian maritime export industry, aiming to hit the terminal right as international oil tankers were maneuvering into their loading positions. The lead munition slammed into a primary pumping manifold at 0645 hours, igniting a petroleum fire that rapidly spread to adjacent refined product pipelines. While the physical damage to the Taman-Naftogaz terminal required millions of dollars to repair, the secondary economic shockwaves were exponentially more devastating. The immediate presence of active combat zones around a major export hub triggered an instantaneous reaction from global maritime insurance syndicates. Premiums for vessels operating in the Black Sea spiked dramatically. Calculations from maritime economists indicated that these insurance rate hikes alone would cost the Russian shadow tanker fleet tens of millions of dollars in additional operating expenses per month. Because these shadow tankers operate on razor-thin margins to bypass international sanctions, the sudden increase in risk premiums severely restricted their ability to profitably export oil. Tanker traffic in the region plummeted as ship captains refused to dock at a terminal that was actively under fire, effectively creating an invisible blockade without Ukraine needing to deploy a single conventional warship. This dual-pronged approach, striking chemical precursors in the Perm region and oil revenue in the Krasnodar region, exemplifies a sophisticated strategy of systematic destruction. By severely damaging the Metafrax plant, Ukraine directly choked the supply of artillery ammunition to the front lines. By simultaneously burning the Taman-Naftogaz terminal, they choked the financial revenue stream required to purchase replacement equipment. The disruption in refined product shipments and the overall drop in oil exports created a compounding crisis for the Russian war economy. The Kremlin found itself bleeding capital, while simultaneously facing critical shortages in explosive materials. The genius of this campaign lies in its asymmetric nature, utilizing low-cost weather balloons and domestically produced drones to inflict billions of dollars in cumulative economic and military damage. This relentless pressure creates a death by 1,000 cuts scenario, weakening Russia's long-term warfighting capacity and setting the stage for significant political leverage in future diplomatic arenas. At 0700 hours, as smoke plumes over the Perm region thickened, Russian electronic warfare battalions frantically analyzed telemetry data. They searched for the signature of weapons that bypassed their billion-dollar defense networks. The genius of the Ukrainian strategy lay in its simplicity. By utilizing weather balloons equipped with solar panels and artificial intelligence navigation, they created an undetectable delivery mechanism. These balloons drifted at altitudes exceeding 30,000 feet, far above the engagement envelopes of standard short-range air defenses like the Pantsir systems. The balloons acted as silent motherships, perfectly insulated from the intense electromagnetic jamming that routinely blinded low-flying drones. This hybrid of 19th-century lift mechanics and modern processing power allowed Ukraine to project force across 1,000 miles of hostile airspace, neutralizing Russia's electronic shield. Meanwhile, the secondary explosions at the Taman-Naftogaz oil terminal in the Krasnodar region continued burning through the morning. The physical destruction of the pumping infrastructure was severe, but the true objective was the destabilization of the maritime insurance market. Russian crude oil exports rely heavily on a shadow fleet of aging tankers that operate without standard Western insurance to bypass global price caps. However, these ships still require specialized maritime coverage to enter the Black Sea. Following the second Ukrainian strike in under a month, underwriters immediately reassessed their risk models. Premiums skyrocketed by over 300% overnight. For a shadow fleet handling millions of barrels, this translated into tens of millions of dollars in unexpected monthly overhead. Every inflated premium dollar is removed from the Russian Ministry of Defense's procurement budget, creating a silent economic strangulation. This systematic destruction forces a catastrophic dilemma upon the Russian military command. For decades, their strategic doctrine relied on the vast geographic depth of the Russian Federation to protect critical infrastructure. Plants like Metafrax and Gubaka were considered untouchable sanctuaries, located far beyond the range of conventional artillery or tactical ballistic missiles. Now, with Ukrainian loitering munitions demonstrating a proven strike radius exceeding 1,000 miles, that assumption of safety has evaporated. To protect their remaining chemical production and oil refining assets, Moscow must now consider relocating these massive facilities even further east, towards Siberia. This is an industrial impossibility in the short term, and any attempt to move critical logistics nodes would inevitably cause massive disruptions. Relocating these assets extends supply lines to the Ukrainian front by thousands of miles, introducing fatal inefficiencies into a struggling war machine. The destruction of the hexamine and urea production lines in the Perm region creates a direct and immediate ripple effect on the battlefield. Without these critical synthetic resins and explosive precursors, Russian ammunition plants cannot manufacture the solid rocket propellant required for their multiple launch rocket systems. Nor can they produce the high explosive fillers for their 152mm artillery shells. The timing of the strike is critical, engineered to coincide with peak consumption rates on the front lines. As Russian artillery batteries burn through their existing stockpiles of munitions, the damaged supply chain will fail to replenish them at the required rate. This chemical starvation directly correlates with high casualty figures among Russian infantry units, as they will increasingly lack the artillery support necessary to conduct offensive operations or defend against mechanized counterattacks. The loss of a single factory 1,000 miles away translates directly into lost battles. Ultimately, this relentless campaign of deep strikes serves a strategic purpose extending far beyond immediate tactical victories. As international diplomats prepare for upcoming peace talks in Geneva, the political landscape is heavily influenced by realities on the ground. By demonstrating the consistent ability to inflict catastrophic damage deep inside Russian territory, Ukraine actively dismantles the narrative of its own military exhaustion. The burning ruins of the Metafrax chemicals plant and the Tamannaftogaz oil terminal serve as undeniable physical proof that Kyiv possesses the technological capability and the strategic will to strike Russia's vital economic and military organs. This fundamentally alters the calculus for the Kremlin. The overarching argument is clear. Continued aggression will result in escalating, unsustainable costs to the Russian state. This systematic degradation of Russia's warfighting capacity strengthens Ukraine's position at the negotiating table, forcing Moscow to face the reality of its vulnerability. At exactly 08:15 hours, the secondary wave of loitering munitions began their terminal descent toward the smoldering Tamannaftogaz oil terminal. Russian air defense crews had been at maximum readiness for over 2 hours, their radar arrays scanning the horizon for any thermal or radar cross-sections. Inside a fortified command bunker, a radar operator noticed a cluster of anomalous returns materializing out of the morning fog. These were not the low-flying naval drones they had anticipated, but aerial assets executing a steep dive from 15,000 feet. The operator immediately relayed the coordinates to a mobile Tor-M2 battery stationed near the primary crude oil storage tanks. The Ukrainian munitions, however, were equipped with updated artificial intelligence flight algorithms that recognized the active radar painting their fuselages. They instantly adjusted their glide paths, initiating a series of randomized evasive maneuvers that forced the Russian fire control computers to constantly recalculate intercept trajectories, burning precious seconds as the distance closed to under 5 miles. By 08:16 hours, the Tor-M2 commander authorized a manual engagement, unwilling to trust the struggling automated tracking system. 2 interceptor missiles erupted from their vertical launch tubes, accelerating to Mach 2.8 within a matter of seconds. The missiles streaked upward, their proximity fuses primed to detonate a cloud of high-velocity shrapnel near the targets. But the Ukrainian engineers had anticipated this exact defensive layer. The lead drone released a precisely timed burst of electromagnetic interference, blinding the incoming interceptor's terminal guidance seekers. As the Russian missiles flew blindly through the digitized static, the drone simultaneously executed a sharp 45-degree banking dive toward the ocean surface. The interceptors detonated harmlessly in the empty sky. The drone had now slipped beneath the effective engagement envelope of the radar systems, leveling out at a mere 10 feet above the cresting waves. The Russian crew had expended their best ordnance, and the target was still inbound, moving at maximum speed. At 08:17 hours, the surviving drone navigated the final 2 miles toward a secondary cluster of high-capacity crude oil storage tanks. Russian personnel on the ground scrambled for cover as the high-pitched whine of the electric motor cut through the coastal winds. The facility's automated fire suppression systems were already struggling to contain the blazes from the initial morning strike, leaving water pressure dangerously low across the terminal's emergency grid. The artificial intelligence module aboard the drone utilized its optical sensors to scan the storage tanks, specifically searching for structural weak points along the welded seams where the metal was thinnest. It locked onto a massive holding tank containing 80,000 barrels of unrefined crude oil. Exactly 14 seconds later, the munition slammed directly into the targeted welded seam of the crude oil tank. The 35-pound shaped charge warhead detonated on impact, generating a hypervelocity jet of molten copper that sliced through the steel hull with terrifying ease. The extreme heat instantly ignited the pressurized crude oil inside, triggering a massive boil-over event. A colossal wall of burning petroleum erupted outward, spilling over the secondary containment berms and flooding the adjacent access roads. The thermal radiation was so intense that it began melting the rubber tires of emergency vehicles parked over 400 yards away. This catastrophic structural failure initiated a chain reaction that forced the terminal director to immediately halt all loading operations across the entire port. By 1200 hours, the strategic reality of the morning's coordinated assaults had fully materialized for the Russian general staff. While emergency crews battled the raging petroleum infernos in the Krasnodar region, logistics officers were frantically assessing the ashes of the Metafrax chemicals plant nearly 1,000 miles to the north. They were staring at an impossible mathematical equation. The frontline artillery batteries were consuming thousands of explosive shells per day,